Hello, how are you doing? So today I will be doing this long, complete Python tutorial, and I will make it really simple. I've created somehow like a blog that can be accessible in my website. You can access it in here, and you can access the source code in here and the channel here. So this whole tutorial will be really a complete tutorial on Python. Normally, if you go under this tutorial or course, you will be really like knowing everything about this language. So it really relies on trustful sources like the Python documentation, like the BIP8. I will include also the guide size of writing some proper code in Python, which is really important, and also like a bonus of some Google style guides as well. The installation, I would recommend you to install Anaconda. That's what I use for my Python and to manage my Python distributions. It's really quite straightforward to install it. Also to install Jupyter. Normally, when you install Anaconda, sometimes it comes also with Jupyter if you choose that. So here you can see that it's also for with Conda. It can be installing. You can install it with Conda or with pip. Conda, it's just also with Anaconda. That's Conda, Python, Anaconda. Don't really think too much about it. Once you get those softwares installed with this quite straightforward command lines, you have it. You have this Jupyter notebook. And next, if you don't want to have the Jupyter notebook, which makes it really easy to learn, or you can also like use this tool, which is Collab Google Jupyter notebook, and it's like Google Colab. Yeah, you can have also notebooks that are online that doesn't require actually from you to this is some code from someone. So this actually doesn't require you to install anything on your laptop. Next can be also to use the Python interpreter, normal Python interpreter, and you can just install it quite straightforward if you want. Yeah, here if you want to get started and to use this Jupyter, online Jupyter, you can just do it here, or maybe add it here. Jupyter notebook from Google, and with the tutorial, like you can have just the normal one, I guess, from here, and you don't need to go to like I will just add them for you with tutorial with getting started. And here normally you have just blah blah blah. Yeah, you have it here. Like you can do whatever I do, like add code and say print hello world. So it will be running, and I will just add this one for you. Maybe it's even better without getting started. You don't really need it. You just follow what I mostly do. You can get it online. Yeah, and here you have hello world. So it executes or print 2 plus 4, and you have it. So so it's 6. Normally this tutorial is intended to really be digging into all the functionalities of Python really with the set of arts without really leaving. I will try to really cover almost everything. That's something that people really I have seen in YouTube. They really don't do, and it's not quite easy to do it since it's really like Python. It's like a very complicated sometimes language if you really dig into it. Like there would be parts maybe you would like to skip or not to skip, or you would like to follow it from the first till the end, since I've had some feedbacks that people really wanted to see like to help them a bit with this coding. So we'll be really going through a lot of things in Python. So you will have the table of contents anyway available. You can go through it, and those are like main functionalities of Python. Classes brief. So we also will be showing the standard library. What does it also have? Like we go from lists and everything till the also the classes, the object oriented object specialities of Python and Python 3. So we will be working mostly with Python 3 or Python 3.9, since it has support till October 2025. So mostly it will be really working. We'll do also like continue on the libraries, and that libraries this can be really helpful. I use most of those libraries on a lot of projects. And virtual environments as well can be really useful. Also, we go into the pip. It's the pip8. It's like the style guide for Python code. We'll go mostly through the table of contents of, let's say, the real documentation. We'll go also like a bonus with Google Python style guides, and I will try to assist you really understand all those points. If somehow like the documentations are not always quite straightforward, I will try to make them somehow not that complicated and a little bit easier to grasp. Next, I will go through some Python libraries that are mostly used and mostly useful. Some Python integrations with other technologies. That's what I was using in other videos. For example, with this Elasticsearch and MongoDB. Go with Python web technologies also that are really useful. Some Python machine learning that can be really useful as well. Python automation and Python coding challenges, and that would be really nice. Can also like add some maybe Python modules. Like it will be really interesting for you to get to see some Python modules or something. I will add it maybe here before the coding challenges. And with the coding challenges, we will really try to really apply all our knowledge. Like we could have done it like after those ones, but I want to let it for later. So because it's the somehow you can find them first. They are quite you can find them everywhere. And for me, the priorities for me is really to understand the concepts, the core concepts of Python, the core concepts of the libraries, and Python modules. And like coding challenges for me, there would be something like to practice a bit the understanding of Python, to practice some other theoretical knowledge, maybe some mathematical knowledge as well, and let's say also to help you go through the hiring process, to go through if you want to go into a big company or a big tech company, or you want to really work an interview or something. That can be something that useful for it. So for me, I will mostly focus on teaching the concepts, and later on this one, because for me it's like just a straightforward implication. If you're really good with the basics and with the core principles of programming, this one would be really easy. So this is basically it. This is the basic outline of the tutorial, course, or whatever you want to name it. So I just invite you to take a seat. I would love you to really subscribe if you haven't subscribed yet. I want you really to get to help this channel to get at least 20k 20,000 subscribers. It will be really, really nice. So that's mostly it. So thank you, and see you on the next videos. Hello, it's Amin here, and I am back with the second episode of this series and of this tutorial. As I said, I will be focusing on Python in depth a bit, and I will be also doing it from the sources that are a bit more legit, like the documentation, the standard documentation of Python, and other standard documentations. So it will be from those serious sources, and I will try to make them as simple as and as graspable as possible. So in this one, we'll get started with numbers, strings, and lists. So this is what with this tutorial, with this episode, you will be really understanding these basic concepts of numbers, strings, and lists, which are really fundamental to really write almost any code, like really almost any code out there. So we can get started with this snippet of code, which shows you that here we have a comment. Here we have a second comment after. This is a variable with an assignment. We have like after this we would have like n. If we try to find what is n, it will be 1, and if we try to find what is, for example, text, it will be this is some text. So we are made easy. We are putting that value we are seeing there inside this variable. So n is a variable here, variable, and n and text, of course, are variables, and text are variables, and we can put anything kind of inside of them. Here in Python, which is something which is really nice, it's not a typed programming language, which makes it a bit more readable. So in other programming languages, let's say in Java or other languages, you will have like something like int something, and down there it will be like string something. So this is mostly a number, an integer, mostly we refer to it, or if it's like this, it's a float. So if it's like this, we'll get to it later on. And this is basically a string. It's a collection of text. It's like just a collection of characters, which is a text. Going forward with this, we will see how we can do a little programming calculator. So this is also like, those are like examples from the core documentation of Python. So in here we can see we can calculate 2 plus 2, like just write it in here and you will have 4. You can calculate 50 minus 5 times 6 minus 36, and you have 30 minus 30, and you will have 20. You will have 20 by 4, and this will be 5. And here you can see, for example, that this returns that kind of floating number we were talking about. So here we go into it. It's the division. It always return a floating point number, which is really important in programming sphere. there is a difference between floating point and integer, normal integer. So this would be a normal integer, and this will be a floating point number. Next will be this is a classic division, as we said, and here we have the float division. If you can remember, it's really also very important. You do it with a double slash. Next will be an operator, which is really important. It's the remainder of the division, and it's called the Modulo Operator. And here, for example, the remainder of division of 17 by 3, it's 2. If you divide 17 by 3, you will have, okay, it's 5, it will be 15, and the remainder of the division of 17 by 3 is 2. So it's 17 minus 15 equal 2. So here you have it. It's like 5 times 3, which is 15, plus 2 equals 17, and this 2 actually is the remainder, and you have it here. It's like the quotient plus the divisor times the divisor plus the remainder. Here we have another operator, so all of those are Python operators. So this is another operator, which is the power. So it's like 5 power 2 equal 25, and 2 power 7 is 128. Now we can go forward, as we have seen before, with those variables. We can plug this value in the variable width, and plug this operation in the variable height, and we will have something like this. 9 is 45 times 20 is 900. And we multiply with height. Here, let's try to access an undefined variable. So we'll have an error. So the error here says, okay, m is not defined. Next forward, if we make an operation with a float, we will have a float even without division, but this float number or floating point number makes the whole operation goes floating point. Here we can do a little operation with tax. Tax is like 12%. The price is this one. So the price with the tax on the price is 12 dots blah blah blah. And here there is a very nice operator, or let's say functionality in Python. It's this underscore. So this underscore is the last let's say the last value stored in Python. So price plus the tax. So here we have the tax is 113, and also if for example this is the last entry, it's 14, so it will be not 13 but more like 14. So this is also to be remembered or known. Also we can round this last price here, can round it to two numbers after the dot. This is mostly all for the numbers. Can go forward with the strings. Here with the strings, we can see that we can have a single quote string. If we make some single quotes, we define a string. We can actually, if you have a single quote inside the string, you can escape it with this on a backslash. It's like you have the normal slash, but you have also the backslash or the anti-slash. So it would be more the anti-slash. And here you can have it doesn't matter even if you have a quote inside, so it will be just apprehended just as a normal quote. Next one forward would be to use also you can use a double quote to surround your string. So this is also a string with double quotes, and also you can insert double quotes inside of single quotes, and also when you have the double quotes you don't actually, if you use this inside the double quote, it will take it literally, because you didn't do something like this. If you do something like this, okay, you will have this, but if you take it just normally like this, it will take it literally. Next one forward will be also kind of it's actually the same. So here you can print this sentence this way with the print function, and it would print it without these quotes. Here you have a string S, which has first line and second line, and this means, with anti-slash as well, means new line. So here S, if we print S without print, this is the functionality of print somehow, is that if you just print S without the print function, you will take it, you will have it as literally entered here. If you do like with the print function, you will have first line, second line. So this is for having a new line. So we have to be careful here. If we do something like print some path, some Windows path, will have something like this, but we can enter it like a raw string. So if we so this is what you have kind of seen here. So if you want to enter it like as a raw string, that's a very powerful let's say it's a very powerful utility. If you do arm here, you have it as raw string, and you can have something like, you can have your path normally without some weird formatting. Here you can have multiple quotes to make a multiple line string. Here, if you do it like this, you have your whole string. This is a usage of like a library or something. You go into a library, you will see the same output. Here we can do some operations on the strings. Can do like 3 times un plus yum. You will have the 3 un plus yum. You can also concatenate 2 strings just this way, with just space between them, and they will be joined together. This is useful if you want to do a text this way. Just do it like this without anything here, and it will be concatenated. We say concatenated or joined together. We have a prefix here. If you want to do prefix plus tone, it won't work because this is a variable. It's not a string. It's not a string like here. If you do like you want to also do it the same way with this kind of parenthesis, it won't work. We'll see how it works, but it won't work this way as well. Here it will definitely work. If you want to concatenate a string variable plus a string, you have to use the plus operator. So here next we'll go to the word Python. I have a variable that has word. So here we can access individual parts of the string. If you want to go to word 0, it's P. So it's the character in position 0. It's something very common in the programming languages. Most of the languages we have strings or arrays. If you're familiar with this, we'll see it later. It's arrays, or in Python they are lists. They are called lists. We'll go to it later. They are accessed the first character, the first individual, the first element of, let's say here, of the string or any other type of collection. It's accessed with the 0, position 0. Here the position 5 is n. Here, if we want to access the last character, it's -1. the second last character is -2, and we go to -6 because the word has six characters. -6 will get us to the first character. Here you can see that if we count backwards, we start at -1. Here, like n, it's -1 because 0 minus 0, they're quite the same. Here we can slice. We have the slicing of the concepts of list slicing. So here we can slice from 0 to 2. If you want to know how this slicing works, so here starts 0, 1, 2, and if we go from 0 to 2, so we will slice just those ones. It's like in between. You can just remember it's this way. For slicing, it's in between. For indexing, it's inside. So we slice from 0, 2, we have pi. We slice from 2, 5, 2, 5, we have tau. If we slice here, we slice till 2, and from 2 to it's like we slice this and we slice this, and we have the whole word. And it will be the same if we slice on another. If we slice on on E, it will be just the same. Let's say if we slice till 2, so it will be just till here. It's 2. If we slice after 4, it will be after 4. This is how we do it. One side slicing. If we try to access a character, an index that is bigger than the length of the string, since it has just 4 characters, we can't go to 42. So we have an index error, strings index out of range. But when we do it with slicing, it's all fine. We just will go to the maximum, or here we will go, if we do from 42 to whatever, it will be just empty string, and it won't be an error. So this is also to keep in mind, which is also maybe useful in some situations. Here we can we will try to change the character of position 0 with G. Here tells you, okay, you can't do that because this is a string. Later on we'll see with lists we can do it, but here it's a string, we can't really do it. Forward going with it. If we wanna do it also for the slice, it doesn't work. But if we want to do, this is a normal concatenation. So if we want, we can't actually change the word, but we can create new words out of it. So we create it out of concatenation. Here we would do the same. And here there is a function that is very useful as well. It's called len. It's the length of S. We have here hello, it's 5 words, and the length of hello is 5. Moving forward, we'll go to the lists. Lists. Before we had like strings, and now we have lists. So lists, they are defined like this, very easy. It's a list of squares. So we have squares. We want to access the square at position 0. We access it. The last square. The last 3 squares here, we have them. The same slicing, the same principles of the strings apply for the lists. Here we can make a shallow copy of the squares. It's just a copy actually of this list. Here there is a difference between shallow copy and deep copy. We will go into it in another video, a more advanced video. For now, you can just think of it just as a copy of squares. Just they share kind of the same memory address with the main list. Here we can do some concatenation, add some bigger lists. Tupes, we can here, if you see in this, we will create some list of cubes, but here you can see in this the cube of 4 is not 65, it's more 64 if we calculate it. So we can here actually in the list we can really replace. It's not like strings, but here in list we can replace the index here by 64, and we will just update the correct value. More forward, we can add a cube with the function append, another really interesting functionality of this. So if we append this number, it's the cube of 6, and we append the cube of 7, we can have the cube of 6 and the cube of 7. Next forward, we have letters from A to G. Okay. Here, if we can replace those letters, for example, from 2 to let's say from 2 to 5, it should be C, D, F. And here, if we want to delete from 2 to 5, we'll do it this way. And if we want just to delete everything, we'll do it this way. And if we want to check the length, it's length of the letters. And here we can see that we can also embed lists into lists. Here, if you see, we have A, it's a list, and N, it's another list. And here we can put actually this list A with the list N inside of a bigger list. And you can see that they don't, even if they don't share the same types, it's totally fine with Python. And here, if we access the x0, it's the first element of the list, it will be this one. And if we want to access the second element of the first list, it will be this, like this. This is how you would do it. So straightforward. Like if you want to do more programming, you can do something even more advanced. And this is mostly it for now. Thank you for watching. Hello, it's Amin another time, and I'm back for the third episode of this series of Python programming. And now we will go through the if, for, and loop statements. Last time we have done some basic concepts of Python programming, and now we will go more into those statements, those basic statements. The first one is if statements. For example, let's say you enter an integer here, let's say it's 24. You have this function which is input, which allows you to, and this is the message of your input here, and this is actually to take the integer of the input. You can just even take dot 0 and it will take the integer. So this one in here, we will take this value and we will give it. Okay, so it doesn't take this kind of value, dot 0, so it's mostly fine. So we'll take the 24. So we'll take x will be equal to 24, and we will evaluate this x. This is what this if statement is doing in here. So it's evaluating x. So in here we see if this x we have is smaller than 0, it's less than 0. If it's the case, we'll put x is equal to 0 and we'll print negative change to 0. If x is equal to 0, this is what is this equal. So those are like conditions. And if statements are like for conditions. So, and this one, it means like else if. We have like if, else, later on we'll see it, else, and we will we go through these conditions and we apply. So else if x equal to 0, we print 0. Else if x equal to 1, we will print single. else we'll print more. So if we run this, they will say it's more. So let's say here we will type -14, and here they will tell, okay, negative change to 0. Let's say here we'll type 1. They will say, okay, single. So this is how basically those if statements work. For the for statements, we do them for looping over the list. Like if you remember, we have these lists from the concepts of lists, Python lists, and there are some lists of words. So here we can go for each word in here, like for word in words, like for W, like for word in words, we'll print the word and we'll print the length of the word, length of W, and you will see here it will be like cut 3, window 6, and definite straight 12. So it's for looping over this word list. There is another function that is called the range function. Let's say we take for I in range 5. So what this is doing is it will go from 0 till for the, it will actually, in here you see that there are 5 elements. So range of 5 gives us 5 elements, and it will start at 0 and stop at this number -1. If we say go, okay, we'll go, this is something that we use pretty much in programming. Actually, instead of going this through this word list with W in words, we'll go through the range of len. We have, like, for example, len of A equal to 5. So it will give us range of len of A, it's range 5. So it will go to range 5, and here it will print I, the I, so it's this I here from 0 to 4, and it will print A of I. So what is A of 0? For example, if you remember the concept of accessing the list from the previous video, it will access this Mari. So we will have this I and this value in here. So that's what's happening. 0 Mari, 1 had, 2 A, 3 little, 4 lamb. Next will be like print the range of 10. Range of 10 is it is an object of type range. So you can also like have range actually has 3 parameters, like the start, the next, the end, and the step. Let's say we have we start at 1, we finish at 10. Instead of starting at 0, we finish at 10, but with step 2. Here, for example, if we do it here, let's say here we'll do 0 len 2. Here we can see that he will do steps of 2. So that's what's happening. This is the step. This is like start, end, step. Sum of range, there is a function that is sum, so we can sum the range of 4. It's like 0 plus 2 plus 1 plus 2 plus 3, and it will give us 6. List of range, it will give us the list of this range, and this range it's a concept that is an iterator, so we will see it later on also on this course. We'll really go into everything, try to do everything in this course. So here we have more on loop statements. We have break and continue, also else clauses. Here we have also an else clause for the loop statements. So let's say here we will see, so okay, we'll go for n in range 2, 10. Okay, we start at 2, and we end up at 10. Here, like this is for n. We can have also nested loops, so we have 2 loops. Here we have, so this n go for 2 to 10, and this x, say like this, x goes from 2 to n. So if n is equal to 2, x from 2 to 2, it's x equal to, n equal 3, it will go from 2 to 3, and when n equal 10, x will go from 2 to 10. So if n module x equal 0, like let's say, what we do here, okay, we have n equal 5, an example, for example, n equal 5, x will go from 2 till, will go from 2 till 5. And what we do here, what we say, this n modulo x equal 0, what does it imply, this kind of condition? It means that n is divisible by x. So if this guy is divisible, n divisible by x, okay, we will print, okay, n equals to x times n by x. So because it is divisible, so that's completely correct. And we will break. So we have it's like just to let you know what does this program does. It's like primarity. It's like prime number detection, or yeah, if it says like if prime number printing, let's say, since we are printing that. So here we are printing all the numbers that are prime numbers from 2 to 10. So what we say, it's each time we'll from those two, from the numbers from 2 to 10, or from 2 to 9, since we will stop at 9, we'll see actually which of those numbers are prime or not. Actually, if they are divisible, by just one number between the first between 2 and 5, or between 2 and n, well, they are not prime anymore, because primes are numbers that are divisible by either themselves or by 1. So here we say it's if, okay, equals to 0, we'll say this, and this is the case where it's not prime. Else, like if we have this, we'll say for this, okay, and of course we break every time. We'll break. And actually, what this else does is, if we didn't hit this break button in here, if we didn't break it, well, we will say, okay, we have found a prime number, and that's what's happening. So 2 is prime, 3 is prime, 4 equals 2 times 2, but it's not prime. 5 is prime, 6 is not prime, 7 is prime, 8 not prime, 9 not prime. So that's basically it, and this is also useful for like programming and programming exercises. Another one can be, we have here the else. We have the else keyword. Here we have the continue. Here the continue, let's say here we will go, okay, let's say this program will find the numbers that are even numbers. If he finds even number, he will say it. If he finds odd number, it will say it. The thing here is, this is also that's why Modulo is so useful in computer science, because we use it a lot. So if we have the division by 2, it gives us 0, so the remainder is 0, so it's an odd number, an even number. Let's say here why we do this continue. So when we go to this if num equal to 0, number equal to if the number is even, okay, we'll say continue. What does continue mean? If you go back to the loop. You don't continue actually here. You continue for the next iteration. You don't execute the code that is here. So go to the next iteration of the loop, or continue executing the loop with the next iteration. Since if we didn't specify this continue here, he will say, okay, this number is, he will print this and this. But because of this continue, he won't print this unless this code doesn't go to this if. So here we can see that it will say, okay, it will say even, odd, even, odd, even, odd. So that's totally fine. Next one is the pass statements. Pass statements are statements that are used as placeholders. We can do it for the while. If we do it for while, the program will stop in here. Like, okay, I have to stop my whole program so I can do something. So we have to stop it. We have to interrupt it. They can also be placeholders for classes. If we will see the concepts of class later on. It's like you want, it's an empty class. You want to just save. You have an idea about implementing a class and you don't want to do it now, so you just save the place for it and you say pass. And it's the same thing for a function that we will see just after this course, and it will be after this video. It will be about functions. And here we'll use it as a placeholder to say, okay, here I will just wait or just save the place for this function. I will come to write it later on. So thank you for watching this video, and hope you understood. If you have any questions, just leave them in the comments, and please help this channel get at least 20,000 subscribers already. So it means a lot for me and for us, and it helps me really do some great content. Thank you. Hello and welcome back. It's Amin, and we are here for the fourth tutorial. And today we will be discussing functions. Yes, I changed the theme of my Jupyter notebook, and you can do it following these two commands. You install Jupyter themes, and you use this with pip, or you can do it with Conda, whatever. And you can do it with this command Jupyter theme -t monochi blah blah blah. If you do it through Jupyter notebook without command line, you can do it this way actually, and you can install from the Jupyter notebook. So we can go forward with the code. Here we will start by defining the functions. Let's say we will define a functions, which is Fibonacci, for example, Fibonacci series. I will define it like this. We start at a equals 0, b equals 0, and while a less than n, smaller than n, we print a, and we print a space, and for a it will be b, it will be the next value of the next one, and b will be a plus b. It's a very recurrent function to develop. So this is Fibonacci of 2000, and you can see how very fast it develops. So this is what is a function. It's a function. It's a function object, fib, and we can do also like name it to make it have another name, like f equals fib, and f of 100. If Fibonacci of 100 is this. It prints the list of the Fibonacci series. 100, not the first 100 ones. Well, we can change it to print like the first 100 ones for an example, like here we have fib till n, and while let's say here we can add like something like count, but we will have 2000 of this, but we can do it till 100. For example, we can add count and say, okay, we will start counting at 0, and while count say less than n. Let's say we'll say, okay, Fibonacci of the first whatever numbers, whatever Fibonacci, the first 100. Let's say we want to make the first 100 Fibonacci element, count blah blah blah, and here we say count count plus equal 1. This is an operator. We will also I didn't talk about it, but we will also have a look at it. It's like equal count plus 1. It's like we increment the count. So instead we'll do just count like this. Normally with this we'll have the whole the first the first n, like do like Fibonacci of 100. We will have the first 100 Fibonacci elements. If you see, that's why I didn't do 2000, because it will take quite a lot of space and a lot of yeah, let's say just a lot of space. For here, it's this one, and let's say Fibonacci of 0. Here it's nothing, because we don't have actually the value of Fibonacci of 0. It's also like it's nothing, since it's not for no elements even for this function. So if we say what is the Fibonacci, the fib0 or print fib0, it's none, it's nothing. Next forward, we'll have another function of Fibonacci, and here we will make a list. Before we have done it in some kind of string with some space, like we end at space. Here it will be like results, and we will append each time the result a. And here we can see that it will return a list. We can do the same, like we can do the same exercise here a bit to practice. I can leave it to you, and you can comment it in the comments if you find how to do it for the first 100 elements. It's going to be a nice exercise. Next forward would be the default argument values. Let's say here we want we have arguments. First we have, in the first function we had just one argument, and now we have we can have multiple arguments. Let's say we have some we have a prompt. It's what we will input when we will answer. For example, for this function we'll have a number of retries. This retries here is it's in here, and it's when you have used all your retries, you will have an error, and each time actually you use this stuff, it will say, okay, you have it's too much retries already, and here you have reminder, please try again, and here reminder when you don't actually. It's like we want you to have an answer in this one, in this list, or in this list, and we'll okay. Let's do it. So do you want to quit? I will do my for retries, so I will just say some stuff that is not in these lists. A. So here I have the error here because I have done a lot of retries. Please try again. We can say, okay, do you really want to quit? Yes, that's enough. But still, this yes is not the correct yes, which is not in this thing. So we just type the normal yes. So it's true, and when you return true, you're out of the. Actually, when you return a value, you're out of the function. So each time you return, you're out of the function. Let's say here no, and it will be also false, but you return a value, so you have a value. And here we return, this is what we call a Boolean. We can go, we'll see in two types also later on a bit, what a Boolean type is. And Boolean is like true or false, 0, 1. They're also quite useful in programming. Also, this value errors and error will also dig into it more in details later on. Here we can change the number of retries. Here the second argument is retries. We can change it. Let's say here we have just 2 retries. I do it 2 times, and the third times they will say, okay, that's too much. You have done your retries. The other one will have 2 retries, but the message, like the reminder here, they say please try again. Here the reminder will change. It will be like something here because we print this kind of reminder here from this function. So if you see, we take that, we always kind of use the same arguments in the function. So we will use here these arguments in the function. So we use these arguments. We say a, okay, come on, only yes or no, only yes or no, and that's fine. And here you say a and okay, I quit, but I do it this way. Yes, it shouldn't be, because there is also a difference between uppercase and lowercase in programming, in case if you don't yet know it. Another thing is scopes and functions. For example, here we define a function, and with the argument it's 1, it's I, and I we define it some way, it's 5, and here we print the arg. Even if we change I equal to 6, but f prints actually prints this one at this place. Actually, it points. Let's say it prints it here when it is since this I is before this one. If this I was, let's say, before the definition of this function, it will be 6. Or if both of those I's were after this function, it will be an error. Or no, it won't be an error, since here in Jupyter, like I is saved. But let's say another G, it will be an error because it doesn't know what is J. So this is for this. Another thing that we have to be very careful is here. For example, this one is not is kind of immutable. But what about if we have a list and it's a list that is kind of mutable? Here we say, okay, I'll equal this kind of empty list, and each time we call f, we with an argument a, we append actually this list with a, and we return the list. If we do it 3 times, actually the list that is inside the function get appended 3 times with the value. So here it's not a list that is empty anymore. We sometimes want to have just an empty list and append one element, or maybe we want this kind of behavior, but we can prevent this kind of behavior of happening by doing it this way. Instead of doing it with like a list like this, we can initialize it as being none, and we say, okay, because if we call it here without calling L, it will be none. So we say, okay, if list is none, list here we do list equal to this, and then we append. So if we retry these ones, okay, no, it's this one. Sorry. So if we because I was doing it on the other. So if we do this function right here, we will reinitialize each time L, which is important for us, and we will have shown the new list. and we can control it. Here we can, for example, if we wanted the list of before, like 2, 3, we will have 2, 3 here. We will append 1, 2, 3 somehow. No, wait. No. F 1, 2, 3. More like this. So we'll have this. If we can control this behavior, this is the main point of knowing this. So it's to keep in mind. Here we have also like keyword arguments. Here, as you see, we have like we define this pouch function. We have voltage, state, action, type, and we print for each one. We print the action, we print the voltage, we print the type, and we print the state. Okay, so here for the first one we say 100. It's totally okay because other ones they are default values. It's one positional argument. This we call it a positional argument. So this one is a keyword argument. So this is what are keyword arguments. We call them keyword arguments. So here we have 2 keyword arguments. We will update both of them, like voltage and action. And here we have also 2 keyword arguments. If you see, we can also swap the keyword arguments, and it won't cost too much because they are keyword arguments. And here we have 3 positional arguments. So here actually this one will go here, this one will go here, and this one will go here. And here we have 1 positional argument and 1 keyword. So this one will go here, and state will go to state. Okay, so we can try to see what it does. So here you can see 1000, and it will just print Steve from Norwegian blue. And here we have action will be Voom. It's Voom, and 1000, Voom 1000, and Norwegian Bloom and Steve. Here we change 1000, and we have it will be the same for 1000. Can also like print something like this for more legibility, because just to have like some separation. This is the new line. It's quite really useful also to use it if you're not new to programming. So you have this one. You have this one with 1000 the same. Here we will change million Voom, so million Voom. Here we'll change Voom 1 minute the same, and here we will change the voltage, stage, and action. So we have like million here, million, and we have stage, it's here, perfect life, it's here, and action is something here, is jump, so it's here, and here 1000 voltage will be 1000, and state will be pushing up the daisies. So this is here the difference between a bit positional arguments and keyword arguments. Here we'll have an error since we need also an argument here, either positional or keyword arguments, but we need it here because it doesn't have a default value. Here we have a little problem, is that actually this keyword argument, like you can't put a positional argument after a keyword argument. If you have positional arguments, they have to be before the keyword arguments. That's the problem here. So non-keyword arguments after keyword arguments. So this is, you can't do this in Python. Next would be a duplicate value of the same argument. Here we know that the first one is voltage. It's a positional argument, and it's the first one. So if you say, okay, I do this first, and we also come and do voltage another time and change it, they say, okay, this is a multiple value assignment or value for argument voltage. And here we will just say some random keyword that doesn't exist, and here unexpected keyword argument. And these are the errors that are binding function definitions like this. Next forward is kind of the same thing here. Like we said, we can do double multiple value for argument, double values for argument. A it's the same. Here this is something we do about unpacking arguments and keywords. So here we will like try to run this. We'll just print this and try to see what it does. So actually, the first here kind can be here. It's this slim burger. Next would be it's a very manicer. So those ones are arguments. Arguments are let's say they are like lists. They are like strings, lists, indexed collections, I would say. An indexed collection, like indexed collection, like a tuple list. We'll go into data structures. The definition between these two is that these ones don't have keywords with them, and those ones, well, like with star, one star, they don't have keywords. But the double star, they have keywords. They have keywords actually. Like normally you can do them with, for example, dictionaries, and we'll see it a bit as well. So those ones we will say we'll unpack them as kind of arguments. So here for arg, in arguments we'll print arg, we'll like print those arguments, and here, okay, we will do a little dash, and here we will print the keywords, and keywords will print the keyword and the value of the keyword. So let's see what it will give us. So here, blah blah blah, do you have this? I'm sorry, I don't, blah blah blah. Those two have kind. Kind is the normal argument we had. Next would be okay, they will print all the arguments. So how many arguments we have? We have two. We have 1 and 2. So when I said like a list, they can be also like this. Yeah, it's like one after the other, yeah, like or like 13, something like this. And this would be like also they will print it like 1, 2, 3. Like those are the 3 arguments. There are 3 arguments. And next one, they are actually, let's say they are the positional arguments. Like just to make them make it a bit more understandable, like with the difference between positional and the keyword arguments. So here the arguments in arguments. So here we see what is these arguments. So this will actually plug them in here. It's like we'll make them as a list. This program will read all those as a list. That's why I was talking about lists. So now when they are unpacked like this, they're unpacked as a list here, and they will be read as a list. So here also, like, we can have like print arguments, and here maybe we can do something like print keywords. And here you will see that, okay, so it's like a list. There is another data structure we didn't go into it. It's called like a tuple, and here it's a tuple, and here will be like a dictionary, the one I was talking about. But we will go into them just to make it easy. A tuple is just a list that is not this is immutable. Lists can be mutable, but tuples are immutable, like unchangeable. Dictionaries, instead of having one to index their entries, they have more like some named indexes. And like you have always this structure of key value, okay? The shopkeeper is Michael, client is John, and sketch is cheese. So this is how it is. So this one it's a tuple, and we loop through the tuple and we show what are the tuple, and here we have the keywords, and it's a dictionary, and we show the dictionary, its key, and the value in the key. Okay. Special parameters. So here we will see something quite interesting. This is a bit how a function in Python like generally can be if you want to do something quite special with it. So here are, if you write some let's say some arguments before this slash, they would be positional only. Actually, they can't be. We'll go through examples, and it will be more easily understandable. Just those ones we can't access them with keyword like we were doing before if they are before the slash, and will be sometimes there are some utility for that. Pos or keyword, here it's positional or keyword, it's like standard, it's like normal, and before this like all the positional or keyword will do them before this, and here after this they will be just keyword only. Like you can't access them without keyword, and we'll see some examples. So here we have like the standard argument, the one we have done it. Here we have position only arguments, and here we can see if we do if there are position only arguments, we have no, we still are in standards. So standards, it's like the same. If we do it with position or keyword, it's all fine. But position only arguments, when we do it with pos only arguments, it works. That's fine. But when we do it with keyword arguments, that's not working. So we got some position only arguments passed as keyword arguments. So here doesn't work. When you do it this way, you have to access it just with position only arguments. If you do it this way, keyword only arguments, you can do it this way because this is just it takes actually just keyword only arguments. So you have really to specify the keyword only argument. So here's some combined examples. So we have position only, standard, and keyword only. So here, if you do it like this, it won't work because this one is not keyword. So if you do it here, it's keyword only. That works fine. If you do it like this, standard keyword only works totally fine. And here, if you do pos only, it has to be just pos like this. So the correct one would be just those two ones here for this combined example. Straightforward, we have this function as well. So we what we want to do here is, okay, we have some keywords like earlier, and we have a name, and we want to see if name it will return name in keywords. Return name in keywords is like it will be a true or false if name in keywords. So here we have something is that's actually name, since we have name, and here we have unpacked those keywords, and one of the keywords is name. It's like we have two values for name. So here we have to do something. Here, for an example of the position only arguments is this one. You will, if you do it just position only, you can just unpack your name value, a name in this dictionary, just unpack it just without any problem. So there is really a utility for having this kind of functions. Another utility of these functions are the arbitrary argument lists. So we have some arbitrary here. We'll write multiple items, files, parameter, blah blah blah, file.write. But we won't go into files since we don't. I'm not opening a file. We'll go just to this one. So if we concat, for example, just this one. So if we concat like arguments, we want to concat a list of arguments with some separator. Here the separator will be this one. So there is a function in Python which is quite useful. It's called join as well. So it's just join around the separator here. So let's say here separator, instead of dot, it will be space. It will be something like this. It must finish. So here we have like a lot. We can have a lot of. We can just give it we do it this way. We can just give it plenty of arguments. We have seen it in a more complicated example before. And this one is explicating it. Unpacking those argument lists. So we have list of range is this from range function. Let's say we have arguments are 3 and 6. So we can actually unpack them like this. Unpack this list in this range, like because you wouldn't do it. You wouldn't do a range of just args because it's a list, but you would do it in a way that's how unpacked. That's how that's our function arguments. So you would do it really this way with because let's do an example. If you do a range of args without it, it's a problem, and you have to do it. It's a list, and it's not with list. You don't have range of list, but you have range of this of tuple. So let's say just to make it easy, like this, it just args is just a conversion of let's say, can't use no. Let's say this way. Just to make it simple, like this one is like a tuple, like just a conversion of the list to a tuple. Like it will convert this thing to a tuple of arguments, which is quite useful. We have something really interesting as well, which is the lambda expressions. Lambda expressions, they are, let's say here we want to make an incrementer. So this is an incrementer of n, and it returns a lambda x plus n. So whatever x, not whatever x you have, but let's say here you have two functions, by just to make it also like understandable. Lambda in itself is a function. This is a lambda expression in itself is a function. So it returns. It's a function of parameter x. So you let's say for n you make it 42. Will make so f, it's you will make a function out of the function. That's why there are two functions here. So here you make n, you fix it for 42. Okay, and here if you want to increment this 42 with 0, it will be 42, and you increment it with 1, it will be 41. So actually what it does, it just it returns to you the value of your initial value plus this second argument f2 f1. This might seem not that straightforward. I will make something more graspable, I would say. Let's say we have a range of 5, list range of 5. Okay, so lambda expressions, they can be really useful in situations like this. We want, for example, have like lambda x square for x in okay, this is our data, for example, and we want to square this data in data. So yeah, lambda x list let's say sorry, it's more, it would be like more list of map. There is like another functionality that is also like useful. It's like you map actually this function, instead of like writing a big function that you will go through the data and go through the loops and stuff. You will map actually this function to this data, and it will be something like this, and it will actually do this function for you. The function, it calculates the square. Let's say the function it's something more complicated. It will be like x square plus max of data x plus max data square. So it can be something like this. So this is what is a lambda function. It actually it comes quite handy to write one-line functions. We'll go into more deeper into the map functions and other functions later on. Also, it can come also very handy. For example, you have some pairs, a list of pairs. They are like 1, 2, 3, 4. And you want to sort them. You want to sort them, for example, on this value. Instead of sorting them on this value, they are already sorted on 1, 2, 3, 4, but you want to sort them on this value. So there is a function in Python, it sorts, and it accepts an argument that is called key, and it can be a function. And here we can put it directly as a lambda function, and we say here we want to sort it on the second element, on this one. Instead of sorting on this one, sort on this one, and we put the pairs. So we have F, O, T, T. So T or T, H, T, W. So they are sorted alphabetically on this order. This is for lambda expressions. Yeah, just to make it simple, they are just one-line functions somehow, some quick and easy way to write functions. Instead of write a big function to say, okay, I want to second blah blah, you can do it in just one line, and they come also very handy. Next forward would be the doc strings. There are ways to document your functions. We'll see here in the coding style that they're also very important. So here, for example, if you have this function and you could document it with docstring, like with this, we have seen how to do the multiple strings this way. in the previous videos, you can write them actually just here after the function, and they will be the documentation of this function. This will be okay, it does nothing, no really, blah blah blah. It can be something else like okay, or function, it takes my function AB, it returns A plus B. We can say okay, addition function of, we can also even write a sum function, for example, sum. Actually this is like it's a function from a Python function. Let's say some like this, and it's also from the style guides to do it this way if this name is used or it's a duplicate or something. So here we can take like args, like we were doing args, and here we can say okay, some function of multiple arguments. We can say that here args can do like something like a tab or something. Some args arguments to unpack in the function. So here we can return sum of args. We can return sum of args. Let's say maybe it will work. So here print sum. Here we have that sum function of multiple arguments, blah 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 blah, and here we can do sum of 1, 2, 3, and here no, we can just sum of args. I guess it will be, yeah. So here we have the sum of 1, 2, and 3. This is also a function of Python. It comes very handy. So we have the last thing before last one is like annotations. They are completely they don't do something to your functions, but they are like metadata to your function. So if you do f of spam, so it tells you that okay, ham is a string, x is a string, and the return should be also a string. It's like some metadata instead of just defining functions like this normally without telling what should be like what type of argument it should be. This can be helpful. This can be helpful, like if you want to make your types more restrictive, and to have like some metadata about them, and restrictive also the return and everything. Last thing we'll see together in this course would be, now that you know how to code mostly, so with this outline you really know how to code. With this with knowing how to code it's nice, but it's better to know also the coding side. There is an extension of this course on the coding side. Here there is already a little snippet on coding, so you know how to code well. So first of all, you use for space indentation and no tabs. So instead of using tabs here like this, you use for spaces, because yeah, it is readable. You can because there are some IDEs, text editors that really take tabs for something else, and yeah, better use spaces, always spaces. verb lines so that they don't exceed 79 characters. So if you have really two long lines like this, you have like a pair like this that is going till like this. This is more than 79 characters. So what you do, you verb them. You put them here, so it's more legible. Yeah, more readable. And yeah, use blank lines to separate functions and classes and larger blocks of larger blocks of code inside functions. So always, yeah, you have a we will see about classes shortly, but always use a blank line after your functions and classes, function definitions and class definition. When possible, put comments on a line of their own, not comments. Comment not here, but more here. Use doc strings. Always use doc strings. Always when you use them. Use spaces around operators and commas. Always like spaces after commas and around operators. It's for readability. It's really useful. There's some people who really don't know how to do this, and this is really important. Name your classes and functions consistently. Classes, they should be named in upper camel case. This way, this is how you name as an upper camel case. For functions and methods, they have to be in lower with underscores, lowercase with underscores. Always use self as the name and the first method arguments. We'll dig into the arguments later, but they are like functions of classes that are inside classes. We will, if you don't know what I'm talking about, we'll dig into it later. Don't use fancy encodings if your code is meant to be used internationally. Python defaults UTF-8, so just don't create some encoding that is not ASCII because it won't be readable. And likewise, if don't use non-ASCII character in identifiers if there is people that speaks different languages collaborate on the project. So that's basically all. I hope you enjoyed it, and I see you for the next video. See you. Hello, how are you doing? It's Amin another time with you, and this time it will be about data structures in Python. So we will go to have Modulo lists right here, and for example, if we want to append to add an element to this list, we would append it this way. We can do it also with another way. It would be to append an element with the slicing of the list we have seen before. And if we slice after the length of A, we can add the elements after the slice. We can also use the extend method. We can add the list to a list. Here we would add an element, and here is to extend the list with another list. Forward, extend, actually there is a difference between extend and append. If we take, for example, if we do an append here, we will have a list, a nested list, which is different than the flattened list here in extend. In here we can also append extend lists this way using the slicing comprehension. We can also insert an element at the index 0, we will insert 10, so at index 0 insert 10, or we can remove an element by its value. Here we remove elements by the value 2, yeah, the element that has the value 2. Here we have the pop function. It pops the last elements of the list and returns it also returns the elements. If it pops it can return it here. So here you can see that it pops the 3 and returns the 3. And we have the A. And also we can pop 1, for example, and it will pop the elements by the index, by the identifier, or by the ID here, which is 1 is 2 that pops out. Next forward would be the clear. So this one will clear the list. Okay, I will just maybe clear the outputs. Clear. We have also delete the list, so it's the same as clear. So it's not delete A here. We have to be cautious if we do a delete A, it's something else. Here we delete we clear the content of the list, but if we delete A, we'll delete the whole variable A, and we'll have name error. A is not defined. Next will be to get the index of 2 would be 1, so it gets an index by the value. If we have 2, it will get the index of the first one. We can count the number of ones. Here we can see how many ones we have. We count the count function, and here we can reverse the list, and we have a list reverse. There is also a function, a way to do it with the slices. And we do it this way. It's a usual way to do it, to reverse the list. We can copy the list in B. There we can copy it this way, either by a.copy or by copying the contents of the list. But if we do something like this, B equal to A, okay, we have B, we have A. So if we change B, B 1, 2, if we change B, we will have B like this, and A like this. So we can also copy it like this without changing the value of A. Using the list as stacks, we can use the list as stacks. We have the append method, and we have the pop methods. From the stack comprehension of data structures, we also have the using the list as queues. So here the stack is last in, first out. Here last in was 5, first out, pop is out 5. And here we have the list as queues. And here we have a list, we have 3 persons, and we will add a 4th one, 5th one, and here we will pop. So here it's our first first in, first out. So this guy was first, so if we pop left, we will he will get out. It's the concept of having a queue one after the other. And here we will pop left, and here we have our queue, and we will have just from Michael, Thierry, Graham that are left in the queue. We can have more list comprehensions. Here we have we are trying to build a list of squares, and we are squaring the elements from 0 to 9. And here we can do the same. We have seen this map function before a bit. So we map this lambda function to the whole iterable here. Next forward, we can, and we use the lists here because map is a map object, and here we have to list it. Here we can also do this kind of list comprehension where we do just x square for x in range. Here we can also create those kind of tuples. We will see tuples just after this one, and we can have like a couple for x in 1, 2, 3, and for y in 3, 1, 4. if x depends of y, we have the combinations here. This is the same as twice in this one. So with list, this is what is list comprehension in Python. So we the outer loop is always here, the inner loop is after it, and we do the condition. So this append, the element you append here is the element you write it here, and this has to be between this this parentheses. Next, we have a vector. We do the list comprehension. As we have seen, we multiply each element by 2. Here we can also like select just the elements that are superior to 0. We can take the absolute value of each element, which is the make them positive. Here we have a list of fresh fruits, and here we can strip. There is a function which is strip, a string function, that we can take out these spaces from it. And we have the list without spaces. We can use the same, create lists, a list of elements from just one variable iteration, and create as much as we want, x3, and we have them here. It's kind of this one. Here we have a little error, just to make you to show you if you don't use actually those parentheses, you have an error. So those parentheses, you have to use them. This one, it will flatten this list. So it's for number. It's number for elements in vector. Elements in vector is this one, and for num in elements, and they take this one, number in elements. We can also do more advanced operations with math, pi, and try to extend the rounding of pi. We can have also some nested lists comprehension. For example, we have a matrix, like we have lists of lists, and it's a matrix, and we can transpose this matrix. Can transpose it the way it is done here. We can see if, for example, this one is a bit more complicated. We can try to see how we do it. First, we try to create a transposed matrix, which is a transposed list, which is empty, and we do the outer loop, and we can append for each loop. We can for each iteration we can append the row of I. Row for row in matrix. So for row in matrix, this is row in matrix, and we'll append the row of I, this one, and we will just append the row of I, row of 0, row of 1 in vertically. We transpose it, or we can do it even just in our more planar way. This one is still using the list comprehension here. Here we can also flatten this list comprehension in here without using it. So with list comprehension, you can really go from 7 lines of code to 1 line of code. Here we have also a quite interesting, you can do it just with built-in functions. Built-in functions, they are really, really strong, and really, they really save a lot of time. In here you have for example, the zip, like list of zip, and you can zip the contents of the matrix. You can just unpack the matrix and try and unzip it. So it will zip this this one, it will zip them like this. It will combine these elements with these elements with these elements in a tuple. We'll see what is a tuple. It's like just think about it like a list. We have talked about it. It's like just some immutable lists. They are like rows in a table or something. We'll go into it here, and this is what zips do, and it makes them like here. So it transposes the matrix as well. Here we can check the delete statement. So if we delete a of 0, we don't have this one anymore. If we delete the slice, so we won't have the slice anymore from 2 to 4, from 2 to 4. So these 2 will pop out, and we can clear the list, and we can just delete the whole variable completely. Here are the tuples and sequences we were talking about. So a tuple, we can define it this way. It's like, okay, it's like you define a tuple like this, for example, name, last name, 1, 2, 3, 4, like a pin or something. And you can access T0 here, for example. You can access it like a list, and here you can view the tuple. It will be between parentheses instead of between brackets, and here you can also combine tuples. So you have this first tuple and combined to this second tuple. It gives you even a combination of 2 tuples. This is what I was saying. The main difference between lists and tuple is this one, is that the tuples are immutable. So if you want to change the value of T0, you can change this value. But you can still have mutable elements in the tuple. So this is, for example, a tuple, and if I want to do V0 of 0 equal 9, I still can do it. I can actually change the value of this one. So tuples are immutable, but if they contain a mutable element in them, like immutable and unchangeable, if they contain some changeable elements inside of them, like a list, for example, we can change that element inside of it, but we can't change this element. Like the element of the tuple, we can't change it. Like this one, we can change, but if we do something like this, we can't do it, since the tuple object does not support item assignment with type error. So next, we can there are 2 special cases actually in the tuple, is to create tuples of 0 elements and of 1 element. So a tuple of 0 elements would look like this. It's an empty tuple, and a tuple with 1 element, we have to leave a trailing comma here after the tuple. So here we see len of empty is 0, but still len of singleton is 1. You can notice here, and it's not the length of the string, but it's length of the tuple. And here you can see that singleton is actually a tuple, and it's totally okay to leave a trailing comma here for tuples. Here we can unpack the values of a tuple to variables. Here you can see that we have the values in here from earlier, from T. And that's mostly it about tuples. Next are the sets. Sets are collections that do not. We create tuples with those curly brackets, and with sets, the printing value, the return value, is the value without the duplicates. If here you see we have apple, and orange, we will have them just once. So that's what we have in this set. So, and we can test if orange is in baskets, and it's really fast membership testing since you have just one element of each. So here they say 2, this is false, this one is in baskets 2, this is not in baskets, so it's false. And here we can do sets of some complicated letters, and here we can see, for example, here we can also see what is B. So here what A minus B is letters that are in, those are sets operations like the mathematical sets. So letters in A that are not in B. A or B is the letters that are in A and in B. A and B, it's letters here, just to say, when I say and, to not really confuse you, when I say A or B, the letters that are, they should be like, letters have to be either in A or either in B. So the whole collection of the letters, like the whole letters from A and B. But when we say A and B, they have to be letters in A and in B. Those are like, if you know the operations from mathematics, they are like those set operations. But if you're not familiar with mathematics, that it's like this. It's like here it's the intersection of A and B, and here it's and also those concepts are mathematical, but also like quite understandable semantically and humanly. And here it's more the union of A and B. Yeah, and here it's the XOR, if you're familiar with this operator, and it's in A but in A or B, but not in both. Not the elements in both the sets. For example, if you see here, we have A, we won't have A here. So this actually you remove this intersection. Actually, it's this, it's A, it's this. Actually, this one it's equal to this one minus minus this one. This is actually even the no. Let's make it this way. We have to. Okay, this is the even the formal definition of what is XOR, or what is the like just all the elements besides the intersections, all the elements of both sets besides the intersection. And this one is equal to this one. Next would be to use sets with list comprehension. All the operations that are in list comprehension are also usable in set comprehension. Next would be the dictionaries. So dictionaries are collections of key value elements. You see here there are plenty of there are key value elements. They are more like this, and you can also add more elements. This is the way you add elements in dictionaries. There is no append method. For example, tell.append something like this x. This gives you an error. Dix has no attribute that is append. Yet you have this assignment here that allows you to add elements to the dictionary. If you want to append the way with which we list, you would do it this way with the assignments. Tell of Jack, we can here instead of accessing the the data with the index, we access it with the key value. So here Jack, here we will access it with Jack, and we access to this information here. If we delete the tel of shape and we create a new one, IRV 4127, so we have the new one without this one. So let's say you want to update this SAP guy with IRV, and you have it this way. So you can also list of tel, like what is tel, like the list. If you apply the lists function on tel, it will give you the list of keys. Here let's say returns the list of keys. Here if you sort tel, so sorted of tel, it's also like it sorts just the keys. So it's always it returns the list of the keys that are sorted. So here Guido Intel. So we have so if the membership we use the membership operator using here. It's to assess the membership in the list of the keys. The same here, we can assess it with not in, and actually it's false because Jack is Intel. So here we can also create a dictionary this way by a list of tuples of value, key value. It's a list of tuples, and it gives us a dict with the dict function. We can create it this way by having two dots here, like between x and x squared. And we can do it this way with the keyword assignments, like with keyword arguments. And we can create the dictionary. Here we can go forward with looping techniques on the dictionaries. So actually, if we want to loop on this dictionary, we will do it with the key value in the dict.items. So we have to specify that's the items, because if we say just nights without items, it's just the keys, like we have seen here. Just thinks about they think about dictionaries in terms of keys. So here we can have it. We print the key and the value. Key value, key value, key value, key value. We can also do this way here. This Enumerates function, which is a very useful function of Python, it gives us a dictionary out of a list. For example, let's say you have a list. You have a list, and this list is it's just a normal list, and you want actually to have this index and the value. So you do this enumerate, and it gives you kind of this format of key value. So key value, key value, key value, and the key of those, it's actually I. Forward would be to have to come back to this zip function. Maybe we understand this better here. Is that here it will combine these two and these two and these two together. It will combine them together, and for each one that is combined together, we'll check the first one and second one. So it will be name, non-slot, quest, this. So what is your name? It is non-slot. Format QA, this way. So zip function can also like return this kind of key value elements, and we use it with this format function. where we insert. We will see more about format functions and outputs in the next chapters as well. And it just plugs this Q in here and A in here. And we have name, quest, favorite, and Lancelot, Holy Grail, blue. Here we can reverse. There are some functions here on looping. You can reverse this range, for example, unprinted. With reverse, we have sorted and reversed functions. Here we have sorted, for example, and we have baskets, and we will sort them alphabetically and print them. We also have sorted offset. We can remove the duplicates, so we can combine multiple functions, and it comes really handy. That's why it's pretty concise to write in Python, since you can combine a lot. And here we can do something even more advanced, and especially sometimes you have some complicated data. It's always better to filter the data first and later on use your data for whatever reason you want to use it. And here you can filter in the data and for value in raw data. If not math.isNone of value, this is what is math is none, and filter data.append. So we add the data, we add the value in the filtered data, and we return the filtered data. So this is it. I hope you enjoyed it. I hope you subscribe, and see you for the next one. See you. Hello, how are you doing? It's Amin here for another time, for another video. For the next one, this one would be about Python modules. And for this one, I would like you really to create, to position yourself in your working repository, whatever it is. And I will show you something. Is that now, today we will, as we are talking about modules, we will create our module, this Fibo, and I would like you, all those files that are actually available in my in the Git repository. You can just go to this one, tutorial, and yeah, you would find them in this link. You would find all the documents link, and you would find it just here. Here it's the Fibo file we have created earlier. Fibo functions we were creating earlier. So in our Fibo file we'll put two functions, fib and fib2, and we'll create also we'll make do a part of the code. If it's one from the command line, we will take the arguments from here to plug them in the function. So that's basically what is this Fibo module is. So here what we can do, instead of writing all this code in our main file, we can import it, and we can import it here if we have it in the same working directory as we have. So here we have the same working directory, so we can import it, and we can just call Fibo, our module, and we call the function, the name function is this one, so it's .fib, and we will do of 1000, and this is the output. It's to calculate the Fibonacci sequence. Next would be to call the second one, the second function. Here we can check the name of the package, of the module or the package with name, underscore underscore name underscore underscore. We can also, instead of accessing those fibo with a dot, we can just import fib and fib2 and print. We can from fibo import fib and fib2, and we can just do fib 500 or fib2 500, and we'll have them. So fib1 and fib2, they are different. Here it's a list, and here it's a string with spaces. Next would be, we can import all the functions in fibo with the white card like this, and we have the fib, and we can also import fibo as fib. We can rename the package name. So here we can have it, and we have like fib dot name, and it's actually the real name of fib is fibo. We have just renamed it as fib here to use it, but the real name is still fibo, and we are using it here. Here we can also, from fibo, we can import fib, as we can rename the function we are importing as Fibonacci, and we can do Fibonacci 500. We can also, and how to do it, we just import it this way. Here we will see some standard modules. That's why here we are using a standard module. We will see how it is working. The way we do it is, let's say we will import sys, and we will import fibo. Just give the output. We'll import sys and fibo sys. So we can import either like this, or we can import both of them like this. And we can, this is a very useful function, it's dir. Dir is like the functions of fibo. So here fibo, we have fib and fib2. We have some built-in functions as well, like name of earlier and other doc and other built-ins. We can also do dir of sys. And here we can see really we have a lot of functions, and one of them so one of them is the one we have here. It's this .argv. So if we go to argv, and we have .argv, in here since we have seen a bit, now you understand what is this one. Something we can do is, for example, you can create a terminal here, like you can launch a terminal in your working directory. That's why I opted for Jupyter Notebook, since it's quite versatile in a lot of ways. Here we will go to, where are we? Okay, we are in Python tutorial, Python module 6, perfect. So, yeah, module 6, perfect. So here we are in our module 6, and we can run Python, and we can, without even running Python, let's say we can like run Python and import fibo, and make like fibo.fib 100, and we'll have the output. This is P, it's for Python, just in order, like you run the Python interpreter, we are running the Python interpreter in our terminal, or we can do something like this. Since our fibo function has, we use the sys, this way if we use the sys this way, we say to the interpreter, for example, if we run fibo.py, or we can do it even with Python fibo.py. Okay. Python fibo.py, yeah, we can enter values as we want, like fibo of 1000, and here this is what is this argument you see here. We say that we will calculate when we are calling it from main, this is main, we call it from this main, and we say, okay, if we call Fibo with the main, this first arguments, this argv, please calculate the Fibonacci sequence of the int of this argv, since we want to take the integer value of this. Let's say here, if we change this one, instead of calculating fib, we can also like calculate both of them, like fib1 and fib2 of the same arguments, and here we would have two lists that are coming up. This one should be saved, and let's say this one. Okay, return results. So let's say, okay, here we don't have a print, so we have to print actually for fib2 we don't have a print function, so here we can print it, and here, yeah, here it prints actually the fib1 and the fib and fib2 functions. So this is basically how to use modules from another file, from the interpreter, from Python interpreter, from the terminal. This is basically how you would do that. Here we can also do a blah blah blah, create a variable, and see there or without arguments. So there without arguments would be, we have this variable a, we have Fibo, the package, and we have sys, another package we imported, and the in, out, and the built-in packages. Let's see now if we import built-ins, and here we can see all the built-ins, let's say the built-ins functionalities of Python. All those ones, you have the errors here, we will get into that. We have the dir itself, we have dict, we have seen that in the data structures, format, all the functions, max, min, next of iterators, we will see that too. Zip, everything. And here if we do length of dir, you can see that it's like something like 153 built-ins. Zip, we have seen built-ins functions and objects that are all important with imported with Python. Here let's have a look quickly about how we would do it if we have like software and we want to see what package is the one under which package. Let's say we want to import, we are at sound and we want to import sound.effects.echo. So we go to sound, effects, echo, and we import this file here as we imported fibo.py here. It's like always, it's a py file. We would import it, and here it's a function in echo, and let's say it has those kind of arguments. We can import it just this way, or we can go from this import echo, and we do, instead of doing the whole thing, we do just this, or from this we import just the function and we call just the function. And from inside the packages we can just go, okay, we are in the root one, we are in some of them. Let's say here we are in sound, and from the, let's say we are here, we will say from some file that is, let's come back here, we are in sound here, so or we import echo. So we are in here in effects. We are in effects. From effects we will call echo. So from dot import echo, it's totally fine. But if we want to go to format, for example, we will. So this is just a sound software. Like you have a sound with formats and effects and filters. Not something like that fancy. and some Python files all over the place. We are like in echo. We take this echo here, and we import it. We want to import something from format, so we will go in the tree. So dot means the current working directory. Double dots working means the upper level. You go to the upper level and you go to format. So it imports this format from effects echo. You're in effects echo, and you can also like do it like this. You go to the previous level, you go to filters, and you import equalizer. Instead of importing the whole filters, here we imported the whole format, and here we just imported the equalizer. So this is basically it, and that's it for this one. Thank you for following, and see you for the next video. Hello everybody. So today we will be talking about input and output in Python, and basically how we manage the inputs, how to read data, and the output, how to put this data to be accessible, visible, or on the prompt or anywhere else. First, we'll see some output formatting. And with this, for example, we can use the F functionality of Python. For example, here, we can embed those variables inside of the string here with this F function. And we have, for example, results of year. We have the variable like this and events. So the parsing of this string uses those curly brackets to embed the variables. Next, with some nice usage of Python style, Python sugar syntax, so we can make millions look just like this. Here we can see that we can use the format function as well, and use those curly brackets as this one is for the first bracket for the first variable. This one is for the second variable, and the second variable we just take two. Let's say we do like two. We use this dot two just to say that this person dot two just to say that this percentage will be printed in a format with just 2 digits after the comma. We can do like dot three, and we will have 3 digits after the comma. Here we can also use str of s. It's like string of s, which is just a basic conversion of s. Here we can do a representation of s, which is actually taking the string literal and putting it inside a string, and you can see that they are quite different, and we'll see more on the difference later on. Here we can transform this number into a string. Like as I said, like string is a string conversion of whatever it's inside. It's a function to convert whatever to a string. Here we can have the embed these values. If we want to embed x and y into a string, we have to convert them to a string, of course, and then concatenate them inside the string of that we want to put them inside, and we can print this string, and we will have x and y this way. And here we have the importance of, for example, the difference between string and the wrapper. So if we put hello in string, we will skip a line here with the. We'll add a new line here after the hello word. But if we do a representation of this string and we try to print it, we'll print it with the new line, the new line, the new line identifier, and this way you can or the new line functionality. And here is the measure, let's say, difference between string and wrapper, str and wrapper function. So here we can see more on wrapper function, as we can enter a tuple in it, and we will have multiple information inside a string. Next would be to format string literals. So we can format them like this way. We can take, for example, okay, we put math, and we can use it inside directly the f function. It's like here we use the f format as we used it first here, and we do dot or dot, let's say here we just say that we take three digits here, or we can have 4 digits after the comma, and it's up to us. Here we can also try to format the values in a table format. Like, imagine if we have, let's say, a dictionary, and we take those items and we put them, and here what we say, this let's say this format is that we say that this name is taking 10 character space. So this 10 is like 10 character space, and this is the same, it's 10 character space. If we say, for example, let's say just 5, just to print like same spacing and to have very nice output, can be very useful for outputting. Here you can see is just 5, and we have this one is more than 5, so we can say maybe it's better for him to be 6, so we have them aligned. Here, let's say we want to add some animals. We can do it the same way we have done it before. How we can do the representation of animals, and this way you can have with this way we can have, it's like wrapper of animals. If we do something like this, would be like let's say this, it would be like something dog as wrapper of animals, plus this would have something, you would have the same. So this is wrapper, and this is let's say string. Here more on string format method. So here you can have format night ni. They will be embedded in those 2 placeholders. You can use identifiers like indexes, and those indexes are for, this is 0, this is 1. If you do 0, 1, they will be like spam and x. If you do like 1, 0, they would be x and spam. Next forward, you would have also you can index them in a key value format. You say, okay, this is the key, this is the value, and you can put in them like food, adjective, and they're here. Next can be also either put them first in a positional argumentation, or like what we have seen in the functions, or as a keyword argumentation. You can have 0, 1, and keyword. Next can be also for if you want to do the table here, you can just zip it and you will have everything in here. Here we can have also this kind of format. We give two placeholders for the first one, 3 placeholders for 3 character placeholders for the second one and for the fourth one, so we can have them aligned. One can do that, for example, in powers, and like here it's more for powers as well, so you can go on and on and on and on. You can also like add 4 is 5 x to the 6 and so on, and you can have something like this. Here 3 we give it 5, 4 we give it 6, and 5 we give it, say, 7, and we'll have a whole table here. And you see it's pretty well aligned everywhere. We can also have some manual formatting. Here we will see this F_2 and F_3, and it's basically the same thing as here. Instead of using this format function and using this this syntax, we use the F_just functionality of representation. So each representation has, or string has, this kind of functionality in it. And you can add, okay, I want 2 placeholders, 3 character placeholders, and 4 character placeholders. And we can just do like this, and here we can say, okay, attack, and this we give it some space, and here can say we do the same like we have done before, and we do 5, and we have 1 here as well. So here it's important to end it with just a space, because the normal ending of the print function is like a new line, and it will just deteriorate. Since we are inside of a loop here, it's better to just have 1 space and add whatever you want. The fill, it's really nice. It will fill your function with zeros on the left, whatever number of zeros. It also works for negative numbers. It will fill them with zeros from the left side. And just keep in mind that zfill, it will fill 7 characters placeholders. Here we have 3 and 4, including the comma and including the sign. So it has to do with the number of characters. Those functions have to do with the number of characters. Zfill 5, it will just print the same number, because you have the length of this string is bigger than the value in zfill. Forward, we can have this old formatting of Python. It's like a modulo. It's like the C formatting, since Python itself is really based on C programming language. We can like open this work file, we read its data, we close it, and now we can like we have some reading and writing files. Let's say you want to read a file or to write in a file. I open it like with writing here, but you can like open here the let's say in this example you want to open a file. There are 2 ways of opening a file. You have the way of opening it with f=open this file, and you would have to close it, and that's when it will come why I was showing you this. You can open it this way and you would have to close it, or you can open it with this with open function, and you don't need to do close. And this is something pretty handy in Python that is not really in other programming languages, or probably not in the ones I know about. Maybe in some new programming languages you have very similar functionalities. So here it does the opening and the closing for you. So here, if you open this one, you say okay, f closed, they will say false. So if you open with this, you have to close it. So if you close, you will close it. If you try to read it, you can't read it because the file is closed. But if you do this one, so you open it and you do whatever you want here. You want to read your data, for example, you can read it, and here you can check if this file has been closed after this function, this with functionality, and here f is definitely closed. So more on methods on those file objects. So you can open this file and write in it with this writing parameter, and you can write in it like first line, second line, and also we can open it and read it. We say okay, we want to read one, print read one is this, and read two is this. So if you open a file and you do f.reads, you will f.reads will read the file and position your pointer, because you would have something like pointers. And if you do, you start your file with the pointer at the beginning, and if you read the file, let's say if you do f.read, it will just read everything and put the pointer down. So if you try another f.read, you can't read anything because there is anything left, because you have read all the file. That's why this first f.read will have some input, and the second f.read wouldn't have some input. So you would read the file just once. Here, if you want to read the lines, so here you have the functionality of read lines. So if you want to read the lines line by line, you can do f1 line read line 1 will get the read line 1, and the read line 2 will get the read line 2, the line 2. There is something else. So if we read all lines, like f.read lines, or even without print, for example, let's say I would just do f.read lines. Here we don't have anything left for these files to read, because all the lines have been read already. So here you have seen, and f.read lines, which is a very useful functionality, is that it returns a list with all the lines. And here you can't read anything else because all the lines have been read following the same constructs about where your cursor or your pointer is on the file. Here you can do the same. You can read it this way for line in F. Like you can actually access your work file with just the for loop. So actually, your F is like a collection of let's say of lines. So if you do like this F, what is this F? Is it's an object. It's an object that takes IO wrapper objects that has this kind of data. And this can be interpreted. It's like an iterator. We have seen iterators, I guess. They are more in the classes objects. So we will have to see iterators very soon as well. So it's kind of an iterator. So we can do like next of F, and yeah, we'll have like we can just comment these ones, and we will have. Yes, we have a line here. So F is like an iterator on the lines. Like in Python, it reads in this language we read files line by line. So the line visualization of a file is quite the thing here. Next would be okay. We open the same file, and we write. We have some value and we try to write this value inside the file. So here we try to write f.write, so it will give us where we have our pointer. So if we try to open this file and check where are we, as f, print next of f, can see here. So we have printed this kind of value. So the string of this value, we converted this value to a string, and we have written this string into this file. So if we open the file as a read mode, let's say, yeah, we have writing mode, we have reading mode, and everything. If we open it in a read mode, we have this kind of answer. Last thing with this episode is that we can deal with JSON data in Python in a very nice way. So we have mostly two functionalities to use with Python that are the most useful. It's the dumps function, dumps x, and load x. So let's say x, it's a list, and you want to dump this x. So we have, this is a JSON, let's say a JSON object. So we can do JSON.dump x in f. You can put this this file in a, you can load the data with JSON to this file. So what is mean JSON.dump xf, and it's not dumps, it's dump. You can put the x data, whatever list or dictionary you have. If you're familiar with JSON are like mostly like dictionaries in Python. And in the internet you have them all around the way, everywhere. It's in JSON. Like if you work with APIs, with the data over the internet, it's mostly today JSON. And here we can read this data. So if we want, we can, and here we load this x with JSON.load. So this is just take these JSON functionalities just to save and load data locally. So that's it for today, and see you in the next episode. Hello, how are you doing? If you're continuing this tutorial till now, it's really great because you will be doing very, very well in Python. So let me reintroduce myself. I am Amin Buluma, and I am working on these tutorials, and I'm trying to really make some great content on this channel. So please, if you're not subscribed, please do so, subscribe, and just subscribe and say, okay, I subscribed, and just share your feedback with the audience. It would be really nice, it would be really appreciated. Okay, next forward, it's errors and exceptions in Python. If you see, errors are really something that comes to you, let's say, every time you use a programming language. And here we can see one of the most basic errors is the syntax error. For example, here we have a syntax error, is that here we write the while loop like this. It just, probably I won't run this one because I would have too much, but I would use something like this. And here we can, let's say, correct this error. So how? So this is, for example, what is a syntax error? A syntax error can be something really basic. For example, the print function in Python 2 was something like this, but now it causes a syntax error. Next are exceptions. Exceptions are those errors. Those are what is an exception. It's an error. When you hear exception, it's synonym to error, and you can have one like this. Let's say, okay, we'll just clear the output. So we see that with a fresh look. So here we have syntax error here, and they say what is the syntax error. Always with errors you can associate them with text, and we will see how we can do that. Here, for example, we have some zero division error. We can't divide by 0. We have some concatenation, some naming errors. For example, spam is not defined. And we have also this concatenation of string and int. We can't do this. If you want to do something correct here, it would be something like this, or it would be something like this. Like either you do the string concatenation, or either you do the int operation. So, but when actually errors are amazing when the compiler doesn't understand you, or you have to answer something different, or even if you put this on the output for someone else, this is what is the understanding behind the error. Let's say that after this tutorial, I will give you a very nice usage of and very fast usage in real life of these functionalities. Here we can handle those kind of errors. So next we have here the exceptions, and now we have to handle those exceptions. And how can we handle those exceptions is this way. Okay. Here we will say we have a new block. It's called the try except. So we will try this kind of let's say we will check some inputs, and we will accept. For example, here this is important to make the user really gives the right value instead of using if else like we were using it. Here we can use, or with counts or something, we can use it with this try except. Let's understand this code first. So here the x will take the int of the inputs, and here you will ask for a number, okay? And here we would have, like, after taking this input, we'll get out of the loop, and if we have a value error, if we don't have a valid number, so we have to try again. And here we will accept also all those kind of errors. If we have some one-time errors, if our code doesn't run, type errors if the typing is not good, or name errors if we have some, let's say, some variable that is not named. We had them already. Type error is name error is this one when the variable is not defined. Type error is this kind of some unsupported operation on the let's say on the by the compiler, doesn't support that operation, or let's say the types, there is some misuse of types, would have a type error. And the one-time error is, for example, when you have some error in your code, and we'll mostly see them. So let's try this type of code. We are mostly interested in this value error. And here we can type like an A. So here they would say, okay, oops, that's not a valid number. And here we don't hit this break. That's the most important. So normally, if he tries here and he has the error here, he will jump directly to this one. And this is where you can enter some other values. So B, and that's not a valid number. 13E, that's not a valid number, but when you give it 12, it's a valid number, so it's fine. I said that there is a use case that I just corrected, I guess, this morning, or before I did it in GitHub, for example. We can really have a look, just a look at it, and how these functionalities are really useful. They can be really basic, and yet their utility is quite useful. So let's say I'm quite interested into this bots and automation stuff, and I have done already a video about how to use LinkedIn for a wide range of stuff. And here I've let's see the commits, for example, and so this is a very nice tool to, if you want to apply for some jobs. Well, yeah, I hope you would learn a lot with me with those tools. I really share a lot of them. So here, let's say this is my commit, and here this guy, Niccolo Mantini, he merged it because somehow it's useful. So what I said, okay, you know something? There is something that can be done in your bot, is that, you know, I was using it and like I've commented, I don't know where is the comment of this, but I don't see it. Yeah, like it's funny how it's named. I said like, okay, at least your code won't crash with, at least with this, the crash will not persist. So there was a crash actually in this code. So when you see a crash or some error that gets out, so I'm using this kind of bot even now, like let's say it's in here, so I'm still using it, so it's here, this easy apply bot. So let's say here I told him, okay, you know something, I used your bot and it's crashed. I was using this bot and somehow it did crash. I did stop from working because of some error in some entry. For example, I'm not going into details. I'm just saying that just to avoid like these crashes, you can just do something really simple. For example, you can okay, unified. Yeah, instead of just having your blocks not surrounded with some try catch, like this block that will be like try except, you can like put them in some try block, like here try, I put everything in this try, like just a try. Like the only thing I changed here is I did this try and I did an except. So I just I tried this whole block and accept whatever exception it is in there, and I print the error. So here you can see that actually this is the error that was there. So we have this error was causing this code to crash. So without my, let's say, my somehow commit on this one, this code for everybody in this world, if he wants to use this kind of tool, he will it will crash at this moment. Okay, you have an error, now your code will crash. But what I with this kind of very simple let's say try except block, the code won't crash anymore, and that's actually what we want, because sometimes codes crash, and this is the utility of this. So instead of crashing every time and rerunning the whole bot from beginning and doing the whole job another time, you can just accept the error and say, okay, we don't care even if it crashes us at this, you can continue. Because somehow, even if it crashes, normally sometimes it does, for example, the job. Let's say, okay, here for example, it did the job, like before the sleeping, let's say. But I'm not really going deep into this. Somehow it seems like working. Anyway, it's better, and in any case, it's better to have your code surrounded in some try catch, let's say blocks. Here we can also create, create some, let's say, handle the exceptions with classes. We will, next one, I guess, this is 8, yeah, next course will be about classes. So let's try to understand this, this code. So here we create a class B that inherits from the class exception. We have the class exception of exceptions. This is the one we use for value, error, blah, blah, blah. This is the one I use as well in here. This is this exception class. and it inherits from this, and we say, okay, this inherits from this, and C inherits from B. What we mean by inherits from exception, it does take all the attributes, methods, whatever, and B class, it's an exception class. For example, you would have runtime error, type error, name error. They would all inherit from exception, for example. C inherits from B, so C is also like an exception class, and D inherits from C, so D is an exception class. And so here from class in B, C, D, try raise CLS. So here raise, it's also a nice keyword to use with try, except we have try, like the ones we have to keep in mind with this error handling. The syntax, let's say the structure, the main functionalities, let's say with exceptions, they are like try, except, and raise now for now, and we will raise this class CLS. We will raise CLS and with nothing. They are like classes. Here we say, okay, we will raise, for example, P or C or D, and except D. When it's D, we'll print D. Except C, when it's C, it's C, and when it's B, except B, and so on. So here we will start with B for class is B class. So B, C, D. So it will be like this. We'll raise first it will raise B, second it will raise C, and third it will raise D. We'll get more into classes in the next course after this one. Just this will give you a little glimpse on how also classes can be used with exceptions. Here we can also try to import sys and try to open this file, and we read it and we do some operation. So if we have an OS error, we will have we can have OS error or value error or whatever error. So here we could not convert data to an integer. So here we have a value error. Actually, we could get. We have read the file, so we're not in this case. We're more in this case where we have some kind of very weird info in this my file text that cannot be interpreted as an integer. So if we want to go to the OS error, it's like we will give it a file that doesn't exist. And here we have OS error and no such file in directory myfile.x. But here we have this myfile.x, and here they can't convert this data into an integer. And here we can use, for example, before this we can use this raise, let's say name error, and here we can get directly name error, or it's stuck, name error. Yeah, normally it should be name error or something. Raise name error, something like this. Yeah, well, it's the same, I guess. Yeah, we have like, name error, unexpected error class, name error. So yes, definitely here we have this raise. And that's what I want to do. So it raises this error and we go directly. We don't go to this first exception, neither it's not this value exception. So here we are still trying to handle multiple exceptions. We have either it's this and we have proper handling, either it's this and we have a proper handling, and either it's whatever error. Here it's a name error, or we can just say exception and we have unexpected error, and here they say what is this error. We can get this info with this, and we can just say, okay, raise exception, and here we raise this exception. We'll raise, let's say, F or something, and here we have some kind of type error exception must derive from basic exception. So here it doesn't actually comes from some basic exception, and still we get in this expected error. Or here we can just do some if else something lol. So we have the syntax error. Okay. No, it would no. We can't actually have from this kind of syntax error. We can't come to this except it should be also syntactically fine. Like it would have it should be like we can do something like this syntax error, and it will go here to the expected error, but it shouldn't be a syntax error. Python should be able to read it and not be something completely wrong. This is for this. No. So here we can also have something like this way. We are trying to do some. Open. Yeah, here we are trying to open some file from the arguments we are passing in, since we are somehow so cannot open. So we are basically in this exception, and we have this else. So we have also we can make like try with except with else. So here we try to open this file. So we get some file name from this argv1. Here we get it. We try to open this arg. For each argv, like arg is like one of the list of argv ones. These ones are let's say it's this package we are getting here, and they are like input variables. Let's say they are input variables that this package can access to your data in here, like to the terminal, let's say, and get some data from it. And here we say from each argument in these arguments here, since we are myself, I am running this Jupyter notebook. Maybe if you run Jupyter notebook, you will have something very similar. But if you run it on an let's say a terminal or another IDE or another coding editor, we would have something different. But what we want here is to get this OS error. It's just an example to have this kind of OS error, and also like we will try to open it. It won't happen, and we will have this problem. We cannot open this file, and we will have something like else. We can print this arg like and has len f.readLines, and still somehow this file, like even if they say we cannot open arg, we still have like this arg. We are still like reading it, and still tells us that it has 12 lines. So sometimes, yeah, even if you have some exceptions of cannot open, you still somehow force them to open. So this is the thing with exceptions. Sometimes it just doesn't work a way, and you can make it work on the other way. So this is somehow the else one. There is there is the finally we'll get to it, but it's to make sure that one has to differentiate else from finally. So this try is, let's say the first one is, we have this. We tried to open, because arg is let's say there are multiple arg in this arg. So we have one that cannot open. So here arg, we have some arg, it's -f. So first one, we have OS value, arg is -f, we can't open it. Fine. We go into the second iteration, and in the second iteration, we have an arg that can be opened. So we try this, we open it, and we don't care about this block, and we go to print it and say, okay, we could print, we have the arg and we have these values. So else can come actually after the except. So we put the except, like we have an exception. If we have an OS error, we print the error. And if we don't have this OS error, we print what we want to print. To make it even simpler, it's just an if we have OS error, we have this, else we have this. So you can think of this except and just think about it as having except like very, it's not an else on some try or something, but it's an else of the except. It's like if OS error, else this. So here we have like two args here. So we have this arg first and this arg second, and one goes here. One, we can't open this -f. And the second one, we can open this JSON. So this is basically what's happening in here. Here we will try to raise an exception with some values inside. And here we can access those values. So we can take this exception and name it whatever we want to name it. And we will try to know what are the qualities of this exception. So what is this inst? So we can normally, sometimes we can just name it E, and here like E. What is the type of E? E is like for exception. So here we have an exception instance with class. We will get to know about it. We have the arguments of E. Those arguments we give in here, we can retrieve them by .args. Next, E. If we want to print E, it's like the str. We'll get to also see this str representation. Normally, classes have this str representation. I didn't include it in the next chapter, but I will include it in a more advanced one for sure. Next would be, well, yeah. Here we have E. So if we print E, we can print directly its arguments. So let's say we can decompress those variables in those arguments in X and Y, and we'll have X, Y equal to this and this. So they are like kind of positional arguments. So it's like a tuple of arguments. So these are mainly how you can access error information. Here we have something that fails, and it's a function, and we'll try to run it. And here, if we have zero division, so we can actually take this, like instead of having, for example, this kind of ugly stuff, well, not that ugly, but something that we don't control, that is not that verbose as well. Like Python is not that ugly, and neither two verbose. When I say two verbose, doesn't output too much of text, or doesn't do a lot of error reporting. But this is, for example, the error output of the Python. The standard Python compiler will give you this output. But for you, you want to handle this error and you want to do just some normal output. And here, say, okay, we are handling this stuff. So instead of having this whole thing here, you just can put just this. And this is what you do with this error handling. You put it the way you want. You print what you want. And this is mainly it with handling those errors. Like, just you take them and do whatever operation you want on them. And here you can also like have like general exception. Like, this is for any exception, exception for any exception. But if you do something like this, you will have the normal exception in here. Exception because it didn't handle this exception. Raising exceptions, so here we can raise this, and we have a name error, and always with the parameters inside. Can raise value error. We don't have any parameters inside. And here we can try and raise and accept when you have this raised. Say, okay, an exception flew by, blah blah blah. And here you can also raise another exception inside this except. So here, except, yeah, we'll just exception flew by, and here you can recall this. He will here it's like he will it will call the last error raised, the last raised error. So let's say. Well, I think you quite get it. Here we have the last one is raise a name error, so here it raises this same name error. If we had some other error, it will raise another error. Can also raise inside of the except. We can also chain exceptions. Here we have raise one time error from exc. So exc is not defined, so now we have this name error. So we can here also have a function that raises an error. For example, let's say function raise IO error. For example, instead of you want to camouflage this raise stuff and just put them in functions, you will just name, okay, try this, and if we have IO error, let's do this. So and here we have some talk. Try to open database. Okay. Yeah, of course, it's an IO error, and here, this is like basic Python ones, and here the above exception has two exceptions. So here we can see that we tried to deal with this exception, and inside of the second exception we are raising a second exception, and here we can do this from exc that we try to do. Well, normally this is the basic syntax for chaining, let's say, chaining exceptions. And here we are trying to do that. Like, from this exception here, like, we will take this exception, and here we will say, okay, failed to open the database from exc, and we have this one-time error. This is somehow how we can chain exceptions. Let's see something like more easy to grasp. Okay, we try to open a file that we do not have, and here we will have like this except OS error, and we will raise this one-time error from none. And here we try to open it because we don't have, let's say maybe we do not have this database with SQL, and here as we accept this OS error, we are raising a runtime error, and somehow we're just obscuring this OS error in a runtime error. Actually, from having an OS error, we say, okay, that's an runtime error. That's not an OS error anymore. Or we can do like we have done before as E, and we do this E, and we will say, okay, now we really chain everything. If we don't chain, we'll have the last one, but if we chain them, we'll have, okay, we have find not found, it's the OS error, and the exception above was the direct cause of the following exception of this runtime error. So this runtime error came after this OS error. So this is basically how to chain those errors. Next would be some user defined exceptions. Okay, here we will have like some error exception, and we can change the output of the input error. We can change. We can have input error. We can have transition error, and we can just put whatever text we want here. Here we can change the message, the expression of that input if we want, and here we can just construct this error. And next, like here we have two classes. We have one class, basic one, two classes that inherits from this class with two constructors, and we will see more classes just next one. That's mostly nothing. You just some you can just, now that we have them, we can just call on them, like raise, let's say raise transition error, and here we have transition error, but we need actually that's the thing about having the, let's say the constructor, so it needs something like three variables, a 2 3, and we have something like this, three arguments, like the constructor takes 3 arguments and you give it 3 arguments. You can do some really, this is like a template. This code is available in GitHub and you can use it if you want. Last one, it's one of also the most useful functionalities in error handling, is the finally. It's the finally keyword. So here, even if you raise this error, he will do this code, whatever happens. So you can do some, hey, try this. Even here, normally he tries this, he will say, okay, I have an error, I will stop compiling. But yet, there is a finally, and it will print this one, this code here. Whatever code is here, it will be printed. Here, you can have some some bool return. For example, we will always return false because the finally here it will return false. Here we will try to return 1, but even with return, even with whatever kind of code inside of the try, it will be overwritten in the finally. So combining return, and because normally in a function the return value is kind of final. But in Python, it manages quite well. Even with return function, if there is a finally, it will return the last value in that finally. And here it returns it, it's false. And here we will have whatever. So here we will try to divide x by y. And if we have 0 division, well, here, if we don't have if we have zero division, we have this. But if we don't have zero division, we have the result. We will print the result. Here we don't print the result here, but we print it in the else, like what we have seen. So this is like a recap of everything we have seen so far today. So it will print the results, and finally it will print this clause whatever happening. And let's see. And if we divide 2 by 1 result, and finally, and if we do the division by 0 finally, and this is this will be just okay, that's the finally clause, and we don't handle this. And yet we can also handle it else, and here we can do except exception print exception has occurred. Yeah, maybe not after the else. Up. Yeah, so here if we have this, and we will have like, okay, exception has occurred if we want to manage this exception. And yes, this is a good case to understand that else and finally should be the last ones to be written, and not have excepts can be seen really like if, else if, and else is the last one and finally. So I guess this code would be accessible. And with this, we finish the course of today. Thank you for watching, and see you. Hello everybody. Today is an important day because we will be talking about one of the most important functionalities in programming, like all of the programming sphere. And it's about classes and objects. In let's say in Python we have this possibility of having this OOPs, like oriented object programming paradigms, and with today's class we will be talking about it. So if you haven't subscribed yet, please subscribe and just say I subscribed in the comment section. It would be really nice, and you will help me get to at least 20,000 subscribers, and that would be really nice, since now I'm around 1,000, and it would help me really upload more quality content for you. So forward going, we'll be also talking about scopes and namespaces. So here we have some really important, let's say, instructions in Python that are called, for example, non-local or global. In here you can see we can say that this spam is non-local variable, and this global is a global variable, and we can put them in a function. And let's see what will happen if we run this function. Here let's say, okay, we have a spam variable. So if we do local variable, because here you can see that in this function we can actually have different functions inside of a function, and we can also actually use the scopes of this function. So here if you see we are just running a scope test, and we are trying to run this scope test, and we'll see print in global scope what is the global one in the scope, like which spam is the global variable. If you see here, spam is not defined. It's not defined outside of this function. So let's see what will happen if we do a scope test. Here we define spam inside of this test of this scope, and we name it first of all like test spam. And if we do local, we will run this function. So we will say, okay, no local, do local. We will have this one. So do local, we will have a local spam. Next, we'll have the do non-local. So we'll have so for do local, the first print is do local. So after local assignments, we have test spam. So it's the local assignments here in the scope test, and we do this local. After we will try to with the scope test, we'll print. Okay, after local assignments, we'll do local. Here we don't print anything, and we'll print after the local assignments what we have. We'll do the non-local, and we see after the non-local assignments what we have. So here after non-local assignments, we have the non-local spam. So here we access this spam actually. This, if you see normally, if we don't do this non-local spam, this spam wouldn't really change. And now we are kind of changing it with this non-local function. And here we will do the do global, which is also very important. We will have a global variable spam, and we will have after global assignments, it's spam, it's this global spam, and we will have do global and print after global assignments. So after global assignments, if you see, we still have our non-local spam. We still have the value that got in the non-local. So here we could do the local. We'll just have local, and it will be normal. Here we have the non-local, so we go and use it on this spam, and here we define spam as global. It's not a local variable anymore, but it's a global. And here it's like we define a spam variable outside this whole scope, and it will be with this variable that is in the outside scope, we will name it global spam. So here after global assignments, we have nothing. Like we have the previous variable of the non-local spam. The most important thing to note is here, if we print this in global scope, what is spam, which is not defined actually outside of this scope test, we can access it, and we won't have this name error. Now we have the global spam in here. Next, so this is basic tests of scope of the scope in Python, and something that is really important to grasp in programming languages. Next would be about class definition. This is how we will define a class in Python. So we have like a class name, and this is the normal syntax how to really write class names. We won't use snake case anymore. We'll use more a camel case with the upper in the first let's say character of the class name. And we have statements, and statements they can be any statements in the class. Here we have a simple class. We'll create some class objects. So we have a class my class, a simple class example, like it's a doc string, and we have an I variable in it, and we have a function in it, which we called a method. A function inside of a class is called a method. So it's a function that has something to do with this self. Self is like the objects of the class. So a class is used to generate objects. So we will use this kind of class objects in this in Python. Something that might be different from other programming language. This self here. So here f of self. And also this self makes you define methods. Actually, if you have some function without this self, it's not a class method. It's like just a utility method, I would say. So here, if you say my class, we can say x. Okay, I have to run this one. You can say it's x. It's my class. We call this. It's like instance of class or object. Let's say x is an object of my class. Those are what we like some OOP paradigm or object-oriented paradigms. Let's say here OOP paradigms, or yeah, say object-oriented programming. This is some object-oriented programming. Next, so we have seen that we can instance the my class class and affect it to X. So X is a class attribute. It's an object of my class. So we can access those variables inside of class with this kind of writing. Can do x.I. We can access it and we can call the x.f, and we will have the hello world. So this is something really important about classes. We can define, let's say, attributes, and we can define methods. So this is called an attribute of the class. You will see that Python deals with attributes of classes. Python deals with oriented objects programming in a very nice way as well. Here we can create some class that is complex, from math complex, and it's like a number. We want to represent a number, a complex number. We'll represent it with the real part and imaginary part. And here we can create a complex number. So here we have x.r, x.I. So x is an imaginary, it's a complex number. So x is complex. I'll do it here. So x is a complex number. Okay? And you have x.r, x.I. We can do something like this. String of x, and well, we can define something like this. Like here this is how we build actually an object of a class. We build it or we construct it. It's like this is the constructor. It's also a paradigm of object-oriented paradigms, and this is a constructor in Python. If you're like doing Java or you have done other OOP languages, this is the constructor of Python, and this is how you would construct this is how you put your class attributes in Python in here. It's like you create a function that is called init, and it takes self as parameter. It's the object, and it takes real part here. So self, we omit it when we call, and this is the real part, and this is the imaginary part. You can also like do something like real part, imaginary part, or image part equal and real part equal, and we'll have them like flipped around. Okay. So we can access them this way with positioning or with keywords. And we just say self.r. It's something really similar to Java. Java, you have this.r, attributes, and then you say self.r, it's real part, and self.I is imaginary part. So here, r and I are the attributes of xr, but not real part. Real part is not an attribute of x. So we have attribute error. So it's more just R. So just to make sure that you do the difference between the constructor parameters and the let's say the R attribute, like the parameters and the attributes of the class. Those are parameters of constructor, and those are let's say attributes of the class. Something that can be really interesting is to have this string. I've talked about it in previous class, and maybe it's not included in this, but I would do it. For example, we can create this function. Can create what is called the string representation of self, and here we can say return We can say return x.r, like we can return like this since we have used this, x.r, let's say plus or minus your, just to avoid x.I, and we can do I here, for example. It will not be crazy if it's done like there is some formatting between negative positive, but we can do something like this if they are both positive, for example, just for the sake of simplicity. You can just name them this way, and here we can say complex just complex like this. Complex like this, and we can do STR of x, and it will say, okay, this is this kind of complex. It's complex 4.5 plus I3. Now this is how we would say what is our complex, or you can just take it off this one. And you have something like this. So this is your complex number. It's like 4.5 plus I30 imaginary and real. So this is the image part is 3, and this is the real part is 4. So this is another functionality of class that can be also very useful, like the string representation. You can actually have a representation of your class. You can also have other kind of representations, like and they are called methods, and we'll talk about them. Here we can see the instance of objects. So, for example, we have a counter, and while this counter is less than 10, we double it, and we print the last counter, and we delete this counter. So here we have 16, but here if we do exclude counter, we don't have this. Yeah, it will talk about this previous. Not here. We can add an attribute that is to the class, since here we still talk about our complex objects. Here it's our normal complex objects, and we can add to it. Actually more attributes, and we can add them and delete them. Here we add them, and we have printed it, and here we have deleted it after having it, and here you can see after deletion, because we have deleted it. Just here we can't access it here. They say, okay, we don't have this attribute. This is how to add and subtract attributes outside of the class, for example, but from the objects. So objects of classes, they can be mutable. Like the attributes of the class in Python can be mutable. You can add attributes without adding them in the class itself. Forward, we have class and instance variable. Let's say here, this is, for example, how you can have a method. This is how you call the method. First, we have seen how we can call the attributes. Here we can say it says objects and attributes. And here we have, it's more how you do like class instance variables and methods. So let's say you have a dog, a class dog that's also like the main. I won't go really deep into how OOP work, but the main usage of OOP is to have some kind of classifications. That's why they are called classes. It's like a class, it's like a factory, it's like something that you can make a lot of it. Like for example, dog, you have a lot of kind of dogs, you have door, a lot of kind of doors. Those are mainly why they are called objects and classes. You can create a lot of objects of the same class. It's like a blueprint, let's say. Just for the ones that are not very comfortable with OOP and how it does work. So let's say we have a dog. It has a kind. It's canine, and this dog has we can initiate. We can create more dogs with their names. So this is the constructor. Here, so we create two dogs. Okay, create two dogs. We have one Fido and one body. So D dot kind, it's canine. Like both of them, they are canine. Like we said that this dog would be always canine. And this is the kind, and we have the name. So we have different names for the same kind of dog. Here we have D dot kind will be canine, E dot kind will be canine, D dot name will be Fido, and E dot name will be body. So they have different names, same kind. Here we can this is something we have. Yeah, exactly. This is something we have to look at. It's how we want to really differentiate the access to those variables, because those are kind of general variables or attributes that can be shared across the objects of the class, and we don't want to change the whole class attributes when we change an object's attribute. So here, for example, let's say we still have the name and we still have add trick, but we want to, for example, add tricks just for Fido, but not for one for Fido and one for E. If we do this, we add for Fido and for body. D.tricks and E.tricks, they would have both two tricks, but we don't want this. We want D have just the roll over trick and E have just the play dead trick, because that's the meaning, that's the semantic of how we want it to be. So instead of having these general tricks in here, we will have it also inside the constructor, and this is why we have this constructor in Python, and this is the utility of this constructor, and this is also the utility of having this difference between having this constructor and having this place for some shared variables. So in Python, it really supports having shared variables and private variables, like public variables and shared variables this way, in this init function and this outside scope in here. So that's why this course is it's better coupled with scoping. So here, as you can see, after running this, we can have each one has his own tricks, because tricks has to do just with the object that the object in that we use, like right now. Here we have some remarks about classes. For example, here we can have this kind of purpose storage, and here, for example, we can we can create a warehouse and print its purpose and region, and here we can just have another warehouse and change the region. Just be careful that this one would be here. We will update this class actually from this one. But you can the usage of class can be something like this. Like, yeah, the good thing about classes is you have just this code that is quite just English. You don't have some quite complicated coding, let's say, syntax, but you more deal with the code as it was English. This is warehouse, this is region, this is purpose, and that's mainly it. Next would be some functions that are defined outside the class. So here we have function that is defined outside the class, and we just say this function is the other function. They are the same functions actually. This one is this function, and g of self it gives this, and h equal to g. So here if we see, you can see the c equals c. Okay, and we can say c dot f. So here f needs x and y. So here we see that definitely f is equal to this f1, and here it will give us, if we give it, for example, 10 and 20, it will take 10, 20, and it will be here 10 and here 30, and it will give us the minimum, so it should be 10. So it is 10. And here you can see that g is this one. It's hello world, so we call it normally. And we can have also h, it will be like g. So we can make methods be equal to each other and call them. So here you can see that actually C has three methods. So you can actually define a lot if you don't want to overwhelm your class and you have some kind of file where you have a lot of functions and you just want class to use those functions. You can just use them this way without too much writing all your methods inside the class. Can come pretty handy. So this is really useful in Python to have methods that are and functions that's equal to each other. Next forward, we can have a bag. So with an init function, an add method, like init method as well, add method and add twice, and you can test it. So we have b equal bag of let's say it takes a list. So we better say, okay, bag of 1 1 1. Okay, so yeah, it doesn't take anything actually. That's the thing. So here it doesn't take any let's say any input, but any arguments. But yet we have also not attributes. So we can do something just normal like bag b dot add 1. And we can do also b dot add twice, say 2, and here we can access b dot data, and this will have add 1 just once and add 2 twice, and it's in here. And another OOP concept in Python or in general, it's inheritance. So this is how you would inherit a class in Python. You would do the new class, like the class you want to create, that wants to inherit from another class, and between parentheses, you would have the class you want to inherit from. It's like the base class. You would have the derived class that inherits from the base class, and it would be something like this. It's something really impressive about Python. It's multiple inheritance. It's also like something in C++, but not much in Java. Java is emulated through interfaces, and it's quite really useful to be able to inherit from multiple classes. So Python makes inheritance from multiple classes possible. So you would do it this way. You can have also like private variables. You would do it like this. Let's say you have this. You want well, let's say that private variables are not something that have got a lot of attention in Python development, and they don't have like a keyword of, let's say, private or something. But you can do a little workaround about it and have like this update. There is this let's say this double underscore. If you do a double underscore this way, it's called like a name mangling. So just, I hope you keep up with me here. Just some Pythonic stuff. You just call name mangling, and you can have this updates method, this update, let's say, attribute that is private just to mapping, and it won't be inherited to the mapping subclass. And let's say do this, and let's say here we have mapping one. It's mapping. It's mapping of an iterable. Let's say give it a list 1 1 1, for example. And here you have m2 equal to mapping subclass, and it takes some keys and some values. Keys, let's say, I believe they are both iterables, and they are like 2 2 2 2 2, and here you have 3 3 3. Okay, fix the position. Okay, it takes just yeah, it's that's the thing. It inherits mapping subclasses. A subclass inherits from mapping, so it inherits from the initial constructor. So this is the constructor, and it inherits from it. And this is the update method. So we have an update method that is different in mapping subclass than it in mapping. But the constructor is quite the same. So here we created a mapping based on mapping, the first mapping subclass based on the second mapping. And here we would say, okay, we'll do an update, m.update, let's say iterable. Here we update with 3 3 3 3, and here if we ms if dot update, it will be something like what we have done first. Would be like 4 4 4, because here with this inheritance you can see that we changed this this method. Here it was just one iterable, and here it's more keys and values. And here we can say, okay, 5 5 5. And here something that is quite interesting is, okay, let's say, okay, here m.update. Here we see that update is an object of mapping. If you see, we have mapping.update, okay, and it's like the method, and ms.update. Here it's subclass of method. And here if we do m.update, here mapping has no attribute update. Normally it should have and let's say, so it's the thing is it's not it will take this, it's not it will take this let's say you won't have it as this, but you would have something, it will be represented by mapping updates, and this is what you would see. So So you see, okay, here, like this update method is like a private class. It's like a private method that is different from this private method, from this method. That's why here we are changing it. That's why we are updating it. So if you kind of like quite get it, is that here this update method is quite different from this one, and here we are, let's say, accessing this method from this subclass, but not really this one. And this is kind of what's happening. And what I want to show is this one. It's like this representation of this mapping update. And you can see it sometimes even in those kind of methods. Update, ms update. So this is basically, let's say, with this name mangling. So you would get like a lot about it to understand it. It's you would say like Python mangling private attributes, and you would see like how Python actually let's say deals with those private attributes. Go up here. I would leave this link in my code so you can have a look into it. Just to let you know, yeah, you can deal with private variables even in Python. So here, yeah, we can't really access this, but we can access this one. If we do something like this, I guess, yeah, that's what I was talking about. So if you want to access this kind of copy here, if you want to access this kind of copy in here, you can access it with this, and this is like a private copy of what you have. So this is a private variable of your mapping. You can't quite have it in here, like for example this one. It's subclass. So anyway, anyway, you have these private attributes that is, for example, in this one. Yeah, in this one, it's definitely related to this one, and the other one would be to the other one, to this one. But it's quite how Python deals with it. If you want to have some private variables in your code. You can also have a use of empty classes. In here, for example, you have some class employee, and you just use it like a placeholder, and you can add the attributes as you want, like you were saying earlier. You can have like this John class here and access its data. A very important, actually, concept in Python or in programming languages are iterators. And we will get to understand them. So here, if you see, if you want to go into this one, we can for elements in this list, we can print elements. So we have this. Or elements in this tuple, we have the elements. Or key in this dictionary, we have the keys. And character in this string, we have the characters. And for line in my file, we have the lines. So this is my file.x. So all of those actually we call them iterables. So we have an iterator, and those are iterables, and that's what I was doing here. Like in this mapping, if you see, I was saying, okay, update iterable, and that was given to them a list or a tuple. So we call them in programming, they are called iterators because you can iterate over them. And we'll say where does it come from. So if we have S, it's ABC, we can create an iterator over this iterable here. This string can be represented as an iterable, and we can have an iterator object. It's a string iterator. Here we can access each element of this iterator by next, like next of IT, next of IT, next of IT. They will give us first value, second value, third value. If we do it another time, it will have an error, stop iteration. We don't have any other value after the C value. And it consumes it. It's like the files. Here, this one, it's definitely an iterator, since after that you can't do it. You can't go over the 11th line. Here we have some iterator for looping over a sequence. Let's say you can change this next. So as we have seen, we have this init functionality method of class. We have the iter of class, so it creates an iterator, and you can have also, you can redefine next. Like if you want to reverse something, you can just create a next that actually goes back, like it will be negative and returns. So here, if we want to reverse spam, we can just reverse it. We create an iterator. We can also like just do it inside here, and we can do an iterator over it, and we can actually do an iterator over the class. And if we do an iterator over the class, it will use this function. So iterator of class will be will just return self, which will be spam, but the difference will be in the next method. So if we go in this iterator, it will be inverse, so maps. So we can have a use of the iter and next, and combine iterators with classes, and they have a lot to do with classes actually, because iterators themselves are classes. And this is an iterator. This class actually defines an iterator. So we define an iterator that is called reverse. Next forward are generators. So we have seen iterators. Now we can see also generators. So here we can generate with this keyword. We can generate data with this keyword. It's called yield. If you use this yield here, each data of this index here, we just use some sugar syntax into reverse. Here you can reverse with this kind of looping, with this kind of entries in the range function. It's like -1, minus step 1 from the other side. And here you can yield each data. You can yield data of index. For example, we just change actually the order. You give it data, and data of let's say the last one, they would say, okay, they will yield that data of that index. So index would start, let's say here at whatever -3, and it will well, not -3, but it will 4. The index will be 3. Sorry, it will be 3, and the data, we will return actually the data of 3, and would be f, for example. And here we can print this flog, and here each time it's like we generate we create this generator. It's a function, and we give just one value, and each time we go into the generator, he will give us one value. So this yield, actually it's yielding just one value. This is the most important instruction in having a generator. So we have also generator expressions. We can sum like we have generators. We can sum them. Here we can chain them like with some join or something. Here we can sum them. Here we can, for example, we have this one. We have x and y, and here we want, for example, to do a dot products, and we will zip them together. We'll have a look into zip. Zip just will take will just join each 2 points together from like vertically. It will join 10 and 7, 20 and 5, 30 and 3, which is quite useful. And for x, y in this zip, and we will just multiply them, like multiply x and y, and in the end we will just sum them. Here and here we can just sum them. Here we will just open this file. We will read the lines, and we will see which words are unique here. Those are all like let's say operations on generators. So those are mostly generators. And here we have, those are the unique words in this file. Here we have valedictorian. We will, let's say we will take the marks of a student GPA and the student name for the students in graduates. Let's say we have this data in some database, and we can get the marks out of them, and we can have the marks on both of them, and we we can define actually marks on. There's some other things we can do, like marks is lambda key, lambda x. With this lambda expressions we have done this things before. We'll just key we'll do it on the let's say x0 if x0 is the student GPA, for example. Last would be data of golf, and here we can just return, if we want to reverse it, we can just return the list. Here we can apply this list function on the generator without forgetting that this is our generator. And that's it. I hope you really enjoyed this one, and see you for the next one. See you. Hello and welcome back. We are really doing really fine with this tutorial already, and we still have mostly just 4 episodes already. And of course, a real Python tutorial wouldn't be enough without really digging into the Python standard library a bit. And we'll do it in somehow like 4 episodes. And in here you can see we have already the first one would be about let's say there are some packages that are really useful. The first one is OS, next is regex, and internet and math in Python. So let's start with OS and the operating system interface. So here we have OS, and it gives us, and if we get the CWD, it gives us the repository where we are working. So I'm working in this repository. So we are in admin, repos, Python Ultimate tutorial. We can check what we have in we can change the working directory, and we check which one I am in, and it is here in this directory. And now I can create a temp there, and we have a 256 output that says, okay, you have done it. And here we can see as well the list. Let's say if 200 temp there. Oh, okay. We should have a 0 return value here. It did the temp there. The other one is 256 is that directory already exists. So make sure that the return value is 0 here. Return value must be 0 for their creation. So here we can check the functions of OS, and there are plenty of them. And we can see that it's quite useful library with a lot of functionalities. Can have some help OS, and we check the help, the official help we have with OS, and you can do it with any of the, let's say, the packages of Python. There's a full help around it, and you can check it out. You can do it for any package. We have also shutl, which is really important as well. We will also change to the directory to our, okay, I will maybe clean this up. And we can change the directory with this one. So anyway, it will restart everything and it will clean everything. And that would, okay. Perfect. So I am back to my directory, and here we can see that we can check the directories we have. Maybe we have also some can do some os.ls maybe. So ls, it's the terminal one, get ls maybe, or see os Python for listing. There is the walk actually, and we will just use this one. Listing trees folder. Here, list there. Okay, I just need the list there. So here we have another one. You can find it in the code. So list there. Or maybe there's, yeah. So list there, we can check if we want some kind of, if we have this pedit or not. I had it in that temp directory of before. Here we can just use, okay, I can copy, for example, let's say I would copy the work file. And we can do all this from Python without using the terminal work file to work file.txt. So here it has returned, so it has been created, and here we can see that we have a work file.txt normally, and it's in here. It's the first one. Here we can move this work file.txt to something else. File.txt to work file.json, and here we don't have the text anymore. We have renamed this work file.json. Can use the wildcards, for example, can check all the files that are .py, and I have no one. Let's say .ipnb, that are Jupyter notebooks, and I have all the tutorials here, from the ultimate tutorial to the last one. The last one will be about virtual environments and packages in Python. For this standard official documentation of Python. we can pick up the command line arguments. Here we can check what are the argv of this. Here you can see that I am using this Jupyter notebook, and it's using those arguments to run my code. Something else would be from another terminal. Let's say I would do some terminal here, and I'll just do this. I do like the Python prompts, like normal Python prompts without the Python, without the Jupyter notebook. I would have something else. Like if you're using something else, it's totally okay if you have something else. Okay, here you can say Python, and here I can put this, and argv have nothing in my argv, for example. I can write some error output. We can redirect the output, the error output, and write something else. Also, next one would be regex, like how to use the string pattern matching. And if you're good with regex, you can find, like here we say, okay, in this sentence we will find all the regex that match this regex, and they would be like food, fair, and fast. Normally, like just starting with F. Like here we say, okay, it starts with F and can contain, and should contain actually just alphabets. And for example, if we do just 2 here, it's 1. No, okay, somehow F, A, Z, maybe second one shouldn't. Yeah, exactly. So this one doesn't work. Perfect. So this is what, if you're good with regex, you would really use this one. Like sometimes regex can be really useful to have phone numbers, emails, that really follows some specific patterns. Also to construct. There are a lot of applications for regex. Here we can also use the find all, use substitute, change some things in here following some regex, and here we can also use this, let's say, this functionality replace, and we will replace 2 by 2. So in mathematics, we can have math.cos, can have the log. Also, there is the random, let's say, package, which is really useful. Random.choice, it will just choose one element of this list, which is really nice. Also, you can create some samples, like 10 samples of this list, and sampling without replacing. Just pick up 10 elements from this list if you want, or from this list, for example, or from whatever, if you really are into something. But normally they can be, they can be just small and big. Normally you have more, why you have way more bigger numbers than smaller numbers is because you have more probability to end up in a bigger number than in a smaller number. So it has to do just with some uniform probabilities. Here you have random.random will return a random float. Random.randomRange range 6 will give you some random from 0 to 5. You can also have statistics, like statistics library. You have some data, you can have the mean on the data, the median, or the variance of the data. Also, like some more variance, maybe standard deviation. Statistics, Python, standard deviation, or you can just do it like from the the variance, like just square roots std dev. Okay, std dev. So here you have the standard deviation. You have also some internet access protocols like libraries that can really be really interesting. For example, here you can access the URL of my tutorial and see where is Python in it. Python, maybe you will have a lot of Python in it. And here, for example, it scraps actually from the, you can see it goes to the HTML response and really reads it as a file, as HTML file as it is. So it's all these things here. Wherever there is a Python, it will output it in an HTML format, tag format. You have some email libs libraries. Here just you need some server running and you would totally be able to use email for this. So this is basically it for this one, and let's do the rest in the next video. Hello and welcome back. So today we will continue forward with the standard library, and we will be talking about dates, compression, and performance in Python. So dates and times can be expressed with the datetime library this way. We can use the date.today, and we will have a date. We can use some formatting if we want. Okay, this kind of format, this kind of format is this kind of format. We can change it as we want, like put the, let's say, the year in the middle, put the day in the end. It's totally up to us. So this is how it is. We can also put the big year, the small year, the big year, and this is how it can be done. So this is for basic format. I will leave it as it is. Here we can have some birthday, and we can do some calculations of around. There are some calendar arithmetic around it. So dot days, we can do dot years. Example, it doesn't have years. Days, and we can just divide it by 365, and we will have like, okay, that's my birthday actually. If you would like to send me some gifts on my birthday, you're most welcome. So I'm already 25 years old and a half and counting and counting. And we can just do some floor operation and it will tell you. Okay, it's math.floor, I guess. Import math. Yeah, so you have math.floor, it's this one. We can compress data. We have a lot of data compression modules. We have zlib, gzip, bz2, lzma, zipfile. All of them, they are for, we will use just zlib for now to compress just basic strings. And here we have 41, the len of this string, which is, let's say, the binary representation of s is something like this. In Python, it's like if we do the binary one, it's something like this. If we want to compress s, can compress it with zlib of s, like t is the compression of z, and it will take only just 37. Let's say the length of this one would be just 37. So I guess like the length of s here would be len. Yeah, I guess it's also 41 characters, so it's totally fine. But here, if we we take this t and print t, we'll have some compression. We have compressed actually this s string into some more compressed t with some zlib algorithms. Can even check what are the algorithms of compress like the compressing algorithms. I think I have made something about it. Yeah, here we have another compress. Here we can decompress t. T doesn't have really a nice way of seeing it, but we can decompress it and see it in the original format. There we can use another compression. Like here this is the compression, and here we have another compression, which is this one. And here we can also like decompress this one, and we will have something decompress t. But like CRC, so doc CRC string compute CRC checksum. So it's more for computing this CRC32 checksum. Maybe it would be something that is quite useful in some kind of compression, say compute. Yeah, there are two different checksums. It's just like basic example of compressing and decompressing data. I would leave you, if you're interested into this, you can check it like quite yourself in the help or in the internet. We can also measure performance of algorithms and of other possible operations in Python, and we do it with this timeit, and which is a very nice library. If you do something like competitive programming, if you want to know where is the bottleneck, what works better in how much time. For example, this kind of algorithm works in this amount of time. It's the, let's say, it's the permutation algorithm. If you want to change the value of a, b, change them to b, a, and here you have a equal 1, b equal 1, you will time it. It's like 0.08 seconds, and here if you're gonna time it, it's 0.07, and this one is the way you do some permutation in Python, which is quite useful as well. This is it for this one, and see you for the next one. Hello and come back. Today is gonna be about tests, templating, multi-threading, and logging in Python. Those modules, or login modules maybe, those modules are really, really useful in Python or any other, let's say, programming language, or functionalities, or software, or anything. Let's say here we do some quality control, and it's just to do a lot with tests. So here we have, okay, we have some values, we compute this stuff. This is a doc string, tells you what's happening, and we can actually import this doc test and test those from the doc test. Okay, and here we can check, okay, attempted 1, failed 0. So here we say, okay, we return, this is the average, and we return this kind of average. If we do something like, okay, we do some kind of error in our implementation, it will quite say, okay, you have a test failed, and it doesn't return this value, it returns some other value. You got this weird value, and you were expected this 45. So you just insert your let's say your expected test results in this doc test. So it can be really, it can come in really handy. I have also some unit tests. Like this is the doctest method, doctest package on module. Here it's the unit test module, and here we can use some. We use, for example, this class, and for us we'll be mostly interested in those lines where we have not set equal, we have just average should be equal 1, and we assert equal, this amount of average should be equal to this one, and we kind of say, okay, if it's not happening, what is happening? And here they say, okay, this test has 1 and everything was okay. So if we have something that is, let's say, we are here, you can see that we are always using this average function. If we do something like +1 as well, here it fails, and of course here it will definitely fail. So here your outputs, you have a failure, we have failure 1, the average is not good, and the assets value is not good. This is for the test, doc test, and unit test. If they ask you in some kind of interview or for unit testing, this is mostly what you do in unit testing. So you test each functionality in a very unitary way. You can test like boundaries. You can test a lot of. You can quite use it quite frequently. I have maybe some project reference, since I talk mostly also about references. For example, let's say this project, and here you can have, there is a testing, a really quite straightforward testing library. Here you can see that with one test you can really test a lot of files, and if you would like some real life examples, I will leave it in here. Okay, I guess everything should be fine now. And here we can do some, we have some output formatting. Like before we have done some basic wrapper, let's say outputs. Here we can do even better. Like here we can say, okay, we have some other stuff. This is too much, and we can just say, okay, wrapper.lib representation of the set of this is something and something else. So it can be really handy sometimes when you want just to just to summarize data or not have too much output. Sometimes you have too much output. Let's say we had some in the earliest, here for example, in the earliest things we had a lot to do with text. For example, we can just put it in here and have something like this. Okay, I don't want the whole input, I just want, for example, to know and locate something where it is, or even in the help, let's say here, like here, this huge list there, for example, like, okay, you can have this kind of, okay, I have this one, this second one, this third one, and I have other ones. So it gives you those first things, these first values, and not the rest. It comes pretty handy instead of having a huge input sometimes. I'll just take it out. Okay. Here we have the preprint function, which is also amazingly used. I use it always. Like you want, let's say you want to print this this dictionary or this object. Here, if you do print, you will print it on one line, which is really not helping to see the indentation, but you can do the preprint.preprint, and you can like see it in a very object manner where you can see a lot of things. You can use also the text wrap library, which can wrap your text to how many characters you want them to be wrapped to, just 50 for example, and you will have 50, 30. If you like writing poems or want to put some poems in a very nice way, or it can have, like text wrap can have some utility. Next would be templating. So yeah, of course I will use templating, all those let's say functionalities that are useful in these cases. So let's say we can create templates in Python this way in the string module, and we can create them as this. We create them in this line. So this is a template with this $sign, and let's say if you want actually to have the dollar, you do double dollars. So here you can have double dollars, you have your dollar, and here you can have dollar codes. It's quite like in the terminal. Sometimes in terminal you with dollar you bash coding, not terminal but bash coding, like this $sign is for variables, and here you can substitute whatever in whatever. So substitute village, the village codes, blah blah blah, and you have like something like this. Each folks send these two codes. Templates, you can have templates. Okay, yes, of course. So here we have like item to owner, and here the dix of item. So we have a dictionary of item, but we don't have actually the owner. So here we have the substitute method. We don't have owner, but we can have also the save substitute. It gives us an error, this one. And we have the save substitute, and we can just save substitute whatever in this. Or just here we can, instead of having this, can do, we give it like nothing, and here we do something like save substitute. And this how it would look like. And yeah, something I didn't mention, it's in templates, it's either use this one, these curly brackets, or you don't use them. It will depend on you, it will depend on the situation you are dealing with. So here this is save substitute. Next forward, there is the time and the path. Like you want to batch rename, and you can, like, this is a use case for templates. You have to rename all this stuff, and you can rename them in this way. And let's say I want to rename them, okay, travel, let's say Hungary or something. And here you can just batch name them. Oh no, actually no. The name style, yeah, it would be like travel Hungary, and here you put travel Hungary. Let's say here you put the name, since we take the name, date and format. You can take name. Name is no, it's number of sequence, not name. Sorry. You put the number of sequence. You put here like the date if you want, and you put here the format. It would be something like enter rename time. Yes, and normally we would have the yeah. Here we have the formats, and here we can check them out. And here we can have like okay, and of course we can do some okay, travel Hungary, let's say it's number and sequence, date, and format. So you can use actually these things. Of course, yeah. Stack. Say okay here or just this way. Got lag in a bit. Okay, so clear output. Okay, talk. Hit this one here, talk. Here we do this, and here we can just remove this day and just the number of sequence and the format, yeah, and you would have something like this. This image is this, and it should be totally fine. Something really interesting in this standard library is the multi-threading. So you can actually, it's a programming concept. It's to have asynchronous, I would say, access to and processing. Let's say you want to access. Let's say you want. Let's see in this one, for example, it's an async zip. We want to do some compression asynchronously. So here we really, if we want to do something asynchronously, we have to, let's say, inherit from this threading thread class, and also it has to have a threading thread init. Here we are doing this asynchronous zip, and we are running this. This is the method, and we run the zip, we zip in this method, and here we say, okay, you know what, we want in the background, we want to assign, we want to zip this in this, and we start, and okay, we have the main program continues to run in the foreground, and we have also background to join when, and here you can wait for the background task to finish, and here after that this line will wait till this finish. Actually, that's the thing. Instead, what's happening is that we can start the program of compressing whatever, and here we say, okay, the main program here we can continue to run in this program, for example. That can take a lot of time. For example, that's why this multi-threading is really important. It's sometimes your program is, let's say you want to compress a lot of files, and with that as well you want to do some other things. Instead of waiting that all your files are being compressed, you can execute this snippet of code, and maybe after this, let's say after this, you want to make sure that this part of code is done synchronously. This is async, synchronously, and you want this part of code done after after actually both of the programs have been executed, than after both executed. So this is how to synchronize and your code, and we call it like multi-threading. It's like I would like explain it just with this example. If you want to learn more about it, I would recommend really to brush up a bit on the programming, the programming basics. But this is how mostly it works. Sometimes you want to have we in programming language would say some concurrent access to either some let's say resource or whatever. That sometimes can take a lot of time. Like for example, it can be really used in scrapping data. For example, scrapping data. Let's say to scrap a website, if you do it like sequentially without and not multi-threading it, let's say you will wait every time till the page loads and getting the data and extracting the data. And like in this program, I would say like there is some bottleneck. For example, if you have some internet issue or you have some fast internet or whatever, if you do it sequentially, these three steps, I would say that it will take a lot of time. That's what I experienced. And for example, one of the solutions to make it really fast is to do it with concurrence, with concurrency and with threading. And I got really fast results. And to do it like synchronously. And also like consuming, for example, the links instead of doing it sequentially. It's both to do them like it has a lot to do. There are some. I will just do some opening for later search from your side if you would like. There is the concept of having workers, and those threads you can open like workers on each thread. Each thread can be associated. That's this threading. It can be associated to a worker, and those workers can go do the job independently from the program. Like you would start them in the background, and they do whatever, and later when they all have done their job, you can do whatever. So this is basically this concepts of threading. So also if you're preparing for some job interviews or you're looking for a job, it would be a topic of question. Next would be the login. It's a really important library in Python, and you can have many levels of login. You have a debug login, an info login, a warning login, an error login, and a critical login. And here you can see that it started from warning till error and warning, error and critical, but it didn't log the debug and info. You can set like login level or something like this at debug level, and you would have all the logins. And this is also very quite useful, let's say, module in Python. And with this, I would have finished this episode, and see you for the next one. Thank you. Hello and welcome with me. It's Amin, and today we'll be doing learning more on lists, heaps, and decimal precision in Python. So we have a paradigm in programming languages, which is an array. In Python, it's more a list, but here we would have an array where we can embed the same type of inputs inside of this array. For example, a list in Python, we can have different types of variables in here. But if we try to do that in an array, it will raise an error. We have two kinds of errors here. We have the type code, which here should be, for example, let's say H for unsigned int. That's what we have done here. For example, assigned int would look something like this, and an unsigned int would look something like this. And in here, we try to say to this array we have something like a list, and they say, okay, you know something, we need an integer is required since you said that it's an integer. So here we just say, okay, we'll just put an integer in here, and the array will be fine. It's just a unit-typed data structure that is like the list, but it's not, because, as I said, the list can have multiple types of values in it. Here you can check some helping with the array and how it is. And we can slice it just the list, and we can do any other operation like just the list comprehension of Python. Next would be bisect. Bisect would be just to have a list of tuples that are sorted, and we want to insert, for example, something that can be really useful. We want to insert value in these scores with maintaining the sorting. So here with bisect we can do it, and here we insert this value inside of this sorted list. So here we can check with some other ways that we still can maintain the sorting, and we can also insert it. It's not that relevant. Next would be the heap. So what would the heap would be? It's more like let's say the heap, it's a data structure, if you're not familiar with it, that has mainly two, let's say, two priorities. It's a complete binary tree. So here you can see it's just a binary tree. And second, it has two structures. It's either a min heap, if the root node of the heap is the minimum of all the nodes and minimum of its children, or it can be a max heap. And this one, for example, that you see here, it's a max heap, where the maximum is in the root node of the structure. And here always the root of each subtree is the maximum of each tree, each subtree, and here it's kind of the same. And this is how we construct this kind of heap. So in computer science, this kind of structure really comes in handy when you want to do some searching algorithms like sorting, heap sorting. So it's coming in hand. And for this heap, it has an array representation. So this is the array representation. This is the first, the root node, and it has those children, and so on and so forth. And in this way, we want to have like a list. In this library, we can use this heap PQ to modelize this and to create these heaps. So we can create a data structure. We have a list of data, and we heapify it, like we transform it to this format, this array here. We can and for the heap we have some kind of operations, like if we want to insert some value in the heap, we will insert it with heap push, because it has to maintain this complete binary tree and the structure, either that in our case, for example, it's max heap. For here, we can check, for example, in data, like let's say just this one, we can check, for example, which is the default heapify or default heapification of our data in Python. And the default, okay. So the default heapification in let's say heapify, it is the min structure. So here we can see that heapify makes the min structure. So here we can check how we would do the max heapification, and we can check the help of heapify. And here we have heapify, heap transfer list. So heap in place of runtime. Okay. I don't know. Like the okay, heap q. Heap, okay, have to heap q. But normally you would definitely find heap push, heapify. Yeah, we have just, it has just normally one, let's say just one one argument functions, heapify. Yeah, it has just one argument, which is heap. So normally they don't offer somehow the max hypification in this heap PQ from the Python library. Maybe we can check that out. PQ max heap Python. So from okay, so yeah, we have something like this heapify max. So if you want to have the, let's say the data, this is for example for min heap, and here would be something for max heap, and here we import this heapify max, I guess. Yeah, and here we have the data, and we have the min heap, and here data, we have the max heap, and here we can check it out. So we can, yeah, we have these two structures and we can use them out. And here we have some operations. For example, we can either push this one value with respect to the structure, and we can pop some items from the heapify. And here we pop this the smallest one here. Like here we can fetch the 3 smallest entries, for example. And here we can, for example, in this case here, for example, we can fetch the biggest entries if we do, because it's the max heap. So this is really handy for calculating max, min. It does the calculation in O of 1. Like if you're good with complexity, in O of 1 time, like it will go just to the root node. So if it's a max heap, we go to the root node. It's min heap, we go to the root node, and it's max and min respectively. Last point would be just the decimal floating point, and here we have like more, let's say, more precision. These are the applications for financial applications, control over precision and everything. And you can see that the rounds are quite, if we do just round, for example, of this, with Python, let's say calculation, it will be 73. But if we do it with decimal, it will be 74, because it will really count all the decimals that are between these two, and it will really calculate them. Like that. Here we can check with the precision. Like if we do something like this, we'll have something like, and it will round it to the plus here. Here we can just check. No. Yeah. Sometimes like we can really get into a lot of precision. For example, we want precision of 36. It goes like on all of the till the 36th, let's say, decimal. So it can come really handy when you do some, let's say, some very precise calculations. And yeah, it is also important when you have, for example, this kind of 5, for example, and you want to round the 5. So here on decimal, it will round it to 74 instead of 73. So those are somehow the differences that you would like to use the decimal library. So this is it for this tutorial, and hope to see you for the next and the last one of this series. See you. Hello and welcome, it's Amin today with you for the last video of this series, and we will be talking about virtual environments and packages in Python. So we have had one video of a tutorial of, let's say, how you would manage modules in Python. And here we'll see how we manage like virtual environments in Python. So here, to create a Python virtual environment, let's say, okay, let's do it here. We'll open the terminal in our working directory. This is the working directory you have access to in GitHub anyway. And here we would use this command. Here, when you use it, we would create, let's say, a virtual environment. If it's not created, so normally I don't have it created in here. It should be so fine. Here, this is how you would do it. If you have like Python 3, it's your Python 3 or whatever. Here, for example, I would say, okay, for me it's P, I guess. Here, you can create this virtual env like this, or we can, and of course, after this is for creating it, and this is for using it. So you would see that here I am working with base. This base is to say, okay, this is, I'm using the, let's say, the Python base. And here I have created my virtual environment. This one has been created somewhere. So it's here, tutorial environment, and here I would source it. So I would use the second command to say, okay, now I have to activate this. I would source this activate, let's say, script that will activate, let's say, this virtual environment. And here you can see that my virtual environment is, I'm working on this kind of Python virtual environment. If I want to install something, so maybe I didn't really mention what are the virtual environments. I would like, it's like a virtual machine, a virtual Python machine where your packages to install, your let's say your settings, your Python settings, everything would be managed in this virtual environment, and it's for managing packages actually. So here, for example, let's say we will install some kind of package. Let's say we'll install this Nova package in here, or whatever other package it can be. So we will install it on this, let's say, on this virtual environment, and we have some. Okay, we have some warnings. So we have some. Okay, let's install something else. Let's install, for example, Flask. It's one of the API, one of the API managers in Python. I've done a video about it, and it's quite very useful. So here we have installed this this package. It's installed. We can install some kind of other package with some specific version. Okay, you have in your environment, like your base environment, some version you work with it, but for some projects you have another version, you would use this specific version on it. let's say okay, you can upgrade it if you want, and here we can show which version we have. Like I just skipped the upgrade one. We can upgrade it as well. So here we can see like this package where it is, and here we can see that it is actually installed in my tutorial environment. And here you can see it's not installed somewhere else on your machine, but it's installed in this environment we have created. Here we can check, for example, the list of packages we installed. So we installed Flask with its dependencies. We have pip, of course, and we have requests, and of course with their dependencies. And what we do, something really recurrent if you work with Python, is this freeze requirement. So we would just freeze those lists in the requirements. So once you can, instead of, like, let's say you collaborate over code and you want to put it on the Git. So I've made another video about Git and GitHub. If you want to put and collaborate, you don't put all the packages, you just mostly put this requirements.txt, and you can, for example, check it out if you want. I just leave all the comments here in the GitHub repository, so you know, and you can use them just as you want and practice them. And for example, you just, when you collect, let's say here you can see the requirements text, it's here. It's a file, it's a text file that would be just seen here. It's a normal text file, and it has all the versions of your modules. And here, let's say you are from another machine, and you want to install those requirements, and you downloaded the code. You just insert here. They say just the installation is satisfied because we installed it on this machine. But if you import your export your code, you would use just the requirements.txt to import all your modules without really taking all the modules with you. So this is really, really handy. And this is it for this one. And hope to see you very soon. Ciao. Hello and welcome. So today will be a bit wrapping up over all this tutorial we have done so far. So just to for you to have access to all your the information needed to understand this tutorial, I will do this video. So here, like, this is the first video, like, for the tutorial. If you want to access to an online version of, okay, go to sites. Normally you go to sites. So if you want to access to an online version of the overview of what you want to do, you have it here. It's the online one. It's like on my blog here. If you want the source code, yeah, you have the source code on my website. But if you want, for example, the GitHub code as well, you would have it here. So here, this is the GitHub for all the code. Maybe I just put my last. I guess I will upload it if I haven't done for all of them. And here for the GitHub code, you can see that you have access to all the Python, the Jupyter notebook I've created. If you want the Python versions, just comment it, and I will maybe, let's say, upload a Python version of all of this. But if you're really comfortable with the, let's say, Jupyter notebooks, you have all of them. For each, let's say, for each tutorial, I have made, let's say, a Jupyter notebook. So you have, and for each video, let's say we have 14 videos, just for you to see. So we have 14 videos that englobe all the Python documentation. So for you to understand that this tutorial has been based on the Python official documentation. So for you to understand, the documentation is in it's written, and I tried, since a lot of people are, yeah, let's say, don't wanna read all of it, because it's not always like quite straightforward to read it. So I have done really a video tutorial from the beginning till the end, and for each part, let's say each section, I've made a special episode for it. So this is what's happening. First, you can come here. You want to have an overview about each, let's say, each tutorial. I would make also a page, for example, for each tutorial. I will make a page, like a specific page where I explain how it is. Like, for example, I would make a page like this that you can access. For example, for this one, I have kind of a page like this. It's just this block is on the build, and I would make like an accessible code in here where you can really have it just online without, and just running it without even installing Jupyter Notebook. Those are the tools I'm using for this tutorial. If you want to install them, you have those ones. I explained how to install them in the first video. You can install them, and for the table of contents, I would rather, like, for the first episode, like, I've created like some episodes. Let's see in here the episodes I've created so far. Duck. Here you can check for each section. It's an episode. So this is the second episode. Duck. Here we can check them out. So the second one is in here. This, all the information that is in the documentation, it's in here. Second one, it's this if for loop statements. It will take all this till here. This for third episode is this one. Fourth episode is the functions. So I really made all the functions quite clear themselves. Next forward would be functions. It's data structures. Actually, you have access to an ordered playlist if you want. It will be this one and this one, like maybe this one, I would say. And here you can check how it is ordered. So we have the first one, second one, third one, fourth one, fifth one is data structures. Sixth one is the modules. Seventh one is the input output. I've done a video on it. And you can access all the documentation online. You can access the videos. Let's say errors and exceptions, they are here. Classes and everything, they are also in here. There are two videos that are uploading right now, like those ones, and we have all the standard library here. Like after like the tour of the standard library is in here, and that's it. I'm uploading now the, let's say, the library, uploading the virtual environment videos, and next I would go with the style guides, and I would go with other, let's say, other things you can do with Python. And I guess next ones would be more about machine learning, for example, and I guess so. Like this is the next one I would be doing, or And I would be doing maybe some coding challenges as well for people who want to get hired and everything. Well, that's basically it. Where you find the information, where you find everything. I just would may have tried to find some time to really structure even more everything. If you really can't find the information, just let me know. I would be really glad to show you where to find any information you want. I thank you very much. If you followed till this episode, I really thank you so much for for everything, and I hope to see you very soon and very soon. I wish you all great luck and see you for the next series of episodes.